Welcome to the Whispering Universes channel, where tonight we embark on perhaps the most profound and unsettling journey of all into the vast silence of the cosmos and the possibility that we are not alone, but simply being watched. As you settle into this moment, breathing slowly and deeply, prepare to explore one of the most chilling yet comforting solutions to the greatest mystery in science. Why? In a universe that should be teeming with life, we seem to be utterly, mysteriously alone. Imagine looking up at the night sky and knowing that among those countless stars, advanced alien civilizations are observing us with the same detached curiosity that we observe animals in a zoo. Picture vast intelligences that have been silently monitoring human development for millennia, carefully maintaining their distance while we evolve, learn, and slowly mature as a species. This is the zoo hypothesis, the idea that Earth exists within a kind of cosmic nature as preserve, with humanity as the protected species under the watchful care of benevolent alien zookeepers. The story begins with a simple question asked by one of the 20th century's greatest minds. During a casual lunch conversation at Los Alamos in 1950, physicist Enrico Fermi posed what seemed like an innocent inquiry: where is everybody? This four-word question would grow into one of the most profound paradoxes in science, forcing us to confront the apparent contradiction between the high probability of alien life and the conspicuous absence of any evidence for it. Fermi's reasoning was elegant in its simplicity. Our galaxy contains hundreds of billions of stars, many of them older than our Sunday. Even if only a tiny fraction of these stars have planets, and only a tiny fraction of those planets develop life, and only a tiny fraction of those develop intelligence, the sheer scale of the galaxy suggests that technological civilizations should be common. Some of these civilizations would have emerged millions or even billions of years before humanity, giving them ample time to spread across the galaxy and make their presence known. Yet when we look out into the cosmos, we see only silence. No alien megastructures dimming distant stars. No clearly artificial radio signals emerging from the cosmic static. No obvious signs of vast engineering projects or galactic-scale civilizations. The universe appears to be a vast, empty stage upon which only one actor, humanity, has appeared to play out the drama of consciousness and technology. This absence has puzzled scientists for decades and spawned numerous explanations. Perhaps life is far rarer than we imagine. Perhaps intelligence is an evolutionary dead end. Perhaps technological civilizations inevitably destroy themselves before they can spread to the stars. Or perhaps, and this is where our story becomes both more hopeful and more unsettling, perhaps they are already here, watching us from carefully maintained hiding places, waiting for us to mature enough to join their galactic community. The zoo hypothesis suggests that advanced alien civilizations have discovered Earth and humanity long ago, but have chosen to observe us from a distance rather than make contact. Like scientists studying animals in their natural habitat, these cosmic researchers maintain strict non-interference policies to avoid contaminating our natural development. We exist within a kind of cosmic nature preserve, protected from outside influence, while we evolve and develop according to our own internal dynamics. This hypothesis explains the Fermi paradox in the most benevolent possible way. We don't see aliens, not because they don't exist, but because they are ethically committed to remaining hidden until we reach some threshold of technological, social, or spiritual development. The silence of space is not empty. It's pregnant with watchers, guardians, and guides who surround us with invisible protection while we stumble through our cosmic childhood. The implications are both comforting and unsettling. Comforting because it suggests we are not alone in the universe, that vast intelligences watch over us with something approaching parental care. Unsettling because it implies that our entire civilization exists under a kind of benevolent surveillance, that our development is being monitored and perhaps subtly guided by forces we cannot detect or comprehend. Consider how this changes our perspective on human history and development. Every great leap forward, the agricultural revolution, the development of writing, the scientific revolution, the industrial age, the information era, might have been observed and catalogued by alien anthropologists studying the natural evolution of technological species. Our wars, our art, our music, our literature, our scientific discoveries, all of it might be data points in some vast cosmic study of emerging intelligence. The zoo hypothesis also raises profound questions about free will and authenticity. If we are being observed and perhaps subtly guided, are our achievements truly our own? When we finally reach out to the stars ourselves, will we discover that our path was nudged and shaped by hidden hands? Or does the very fact that we can conceive of such possibilities suggest that we are approaching the threshold where the cosmic quarantine might finally be lifted? Recent developments in astronomy and UFO research have given new urgency to these questions. The discovery of thousands of exoplanets has confirmed that Earth-like worlds are common throughout the galaxy. Government acknowledgement of unidentified aerial phenomena has legitimized scientific discussion of possible non-human technology operating in our skies. The search for extraterrestrial intelligence has expanded beyond radio signals to include searches for alien megastructures, unusual atmospheric compositions, and other signatures of advanced civilization. Each new discovery brings us closer to answering Fermi's question, but perhaps more importantly, it brings us closer to understanding our place in what might be a carefully managed cosmic ecosystem. If the zoo hypothesis is correct, then we are living through the final chapters of humanity's isolation. We may be approaching the moment when our cosmic guardians judge us ready for contact, when the invisible barriers that protect us are finally lowered, and we take our first tentative steps into a galactic community that has been patiently waiting for us to mature. Tonight, as we explore this possibility together, we'll journey through the scientific foundations of cosmic loneliness, the elegant explanations that the zoo hypothesis provides, and the mounting evidence that we may indeed be watched by intelligences whose technologies and ethics are so advanced that they can observe us without being detected. We'll consider what it might mean to graduate from cosmic childhood to galactic citizenship, and how first contact might unfold when our alien guardians finally decide we're ready. As we begin this exploration, let your mind expand into the vast spaces between stars, where ancient civilizations might be conducting the greatest scientific study ever undertaken, the careful observation of a young species learning to comprehend its place in an infinite cosmos. The watchers may be closer than we think, and the moment of revelation may be approaching faster than we dare to imagine. Let the gentle currents of cosmic possibility carry you forward as we dive deep into the greatest mystery of our time. On a summer day in 1950, 4 brilliant minds gathered for lunch at Los Alamos National Laboratory, where they had recently worked together on the Manhattan Project that ended World War II. Enrico Fermi, Edward Teller, Emil Konopinski, and Herbert York were discussing a recent cartoon in The New Yorker that depicted aliens stealing trash cans from New York City. The conversation meandered through UFO sightings, the possibility of faster-than-light travel, and the likelihood of extraterrestrial visitation. Then, in the middle of this casual lunch conversation, Fermi suddenly exclaimed, "Where is everybody?" His 3 companions immediately understood that he wasn't asking about missing colleagues or tardy waiters. Fermi had just articulated what would become known as the Fermi paradox, the profound contradiction between the high probability of extraterrestrial life and the complete absence of any evidence for it. Fermi's question wasn't based on wishful thinking or science fiction speculation. It emerged from rigorous scientific reasoning applied to observable facts about the universe. The physicist had been quietly calculating in his head, working through the implications of what astronomers knew about stellar formation, planetary systems, and the age of the galaxy. His conclusion was startling, even with conservative estimates about the development of life and intelligence. The galaxy should be teeming with advanced civilizations. The mathematics that troubled Fermi are even more compelling today. Our galaxy contains approximately 400 billion stars, many of them older than our 4.6 billion-year-old Sunday. If even a tiny fraction of these stars have planets, and we now know that planets are common, And if even a minuscule percentage of those planets develop life, the numbers quickly become overwhelming. Even if intelligent, technological species are extraordinarily rare, arising on only one planet in a billion, there should still be hundreds of technological civilizations in our galaxy alone. But the truly unsettling part of Fermi's calculation involved time. Some of these hypothetical civilizations would have emerged not thousands or millions of years before us, but hundreds of millions or even billions of years earlier. Given the exponential growth potential of technology, a civilization with even a modest head start should have had ample time to spread throughout the galaxy multiple times over. Where were the obvious signs of such expansion? Where were the megastructures, the radio signals, the visible modifications to stellar systems that should mark the presence of advanced civilizations? Frank Drake formalized these intuitions in 1961 with his famous equation, breaking down the probability of communicating extraterrestrial civilizations into component factors: the rate of star formation, the fraction of stars with planets, the number of planets per star that could support life, the fraction that actually develop life, the fraction that develop intelligence, the fraction that develop technology capable of communication, and the length of time such civilizations broadcast detectable signals. Even with conservative estimates for each factor, the Drake equation suggested that dozens or hundreds of communicating civilizations should exist in our galaxy at any given time. Yet despite decades of increasingly sophisticated searches, we have detected nothing that unambiguously indicates the presence of extraterrestrial intelligence. The Great Silence, as it has come to be known, deepens with every passing year of fruitless searching. The Fermi paradox has only become more acute as our understanding of the universe has expanded. The Kepler Space Telescope revolutionized our knowledge of exoplanets, discovering thousands of worlds orbiting other stars. Many of these planets lie in the habitable zone around their stars, where liquid water could exist on their surfaces. The discovery of potentially habitable exoplanets, like Proxima Centauri b, just 4.2 light-years away, has brought the possibility of nearby alien life into sharp focus. Meanwhile, advances in astrobiology have revealed that life on Earth emerged relatively quickly after the planet became habitable, suggesting that the transition from chemistry to biology might not be as difficult as once thought. Extremophile organisms have been discovered thriving in environments once considered impossible for life. Deep ocean trenches, highly acidic hot springs, areas of intense radiation. These discoveries have expanded our conception of where life might exist and how resilient it might be. The psychological impact of the Fermi paradox cannot be understated. Carl Sagan once observed that the universe seems like an awfully big place to waste if we're the only intelligent species in it. The possibility that humanity represents the only conscious observers in a vast, empty cosmos is both humbling and terrifying. It suggests either that intelligence is far rarer than we hoped, or that intelligent species face challenges that consistently prevent them from achieving long-term survival and expansion. Some scientists have attempted to resolve the paradox by arguing that our search methods are inadequate, or that we haven't been looking long enough. Perhaps alien civilizations use communication technologies so advanced that we can't recognize them. Perhaps they've moved beyond radio waves to quantum communication or other exotic methods. Perhaps they're deliberately hiding their signals from primitive civilizations like ourselves. Others have suggested that we're looking for the wrong signatures entirely. Maybe advanced civilizations don't build massive radio transmitters or obvious megastructures. Maybe they've learned to live in harmony with their environments, making their presence nearly undetectable to external observers. Maybe they've transcended physical reality entirely, uploading their consciousness into virtual worlds where they can explore infinite possibilities without the need for interstellar expansion. But these explanations, while possible, seem to multiply assumptions without necessarily resolving the fundamental puzzle. Why would all alien civilizations choose the same path of hiding or transcendence? Why would none of them leave obvious traces for younger species to discover? The uniformity of the silence suggests something more systematic than random technological choices. The Fermi paradox has inspired a cottage industry of proposed solutions, each more creative than the last. Perhaps we live in a computer simulation run by advanced aliens studying the development of virtual species. Perhaps intelligence is an evolutionary dead end that consistently leads to self-destruction. Perhaps we exist during a unique window in cosmic history when technological civilizations can emerge. Perhaps aliens are already here but remain hidden for reasons we can't yet comprehend. Among all these possibilities, the zoo hypothesis stands out for its elegant simplicity and its optimistic implications. Rather than requiring that intelligence be rare, self-destructive, or invariably transcendent, it suggests that alien civilizations are common but ethically committed to non-interference with developing species. We don't see them not because they don't exist, but because they've made a conscious choice to remain hidden until we're ready for contact. As we continue our exploration tonight, we'll discover how this simple idea that we live in a cosmic zoo under the benevolent care of alien zookeepers provides compelling answers to the deepest questions raised by Fermi's innocent lunchtime inquiry. In the search for explanations to Fermi's troubling question, perhaps no concept has proven more influential or more chilling than the Great Filter. Proposed by economist Robin Hanson in the 1990s, this hypothesis suggests that somewhere between the emergence of life and the development of galaxy-spanning civilizations lies a barrier so difficult to overcome that virtually no species manages to pass through it. The question that haunts every discussion of the Great Filter is perhaps the most important one facing humanity. Have we already passed through this cosmic bottleneck, or does it still lie ahead of us? The Great Filter concept emerges from a simple observation. If life and intelligence are common in the universe, as the Drake equation suggests they should be, then advanced civilizations should be everywhere. The fact that we see no evidence of such civilizations implies that somewhere in the chain from simple chemistry to galactic empire, there exists a step so improbable or difficult that almost no species manages to complete it successfully. To understand where this filter might be located, we must first map the major evolutionary transitions that led from the primordial Earth to human civilization. Each step represents a potential bottleneck where cosmic evolution could stall, leaving countless worlds populated by simpler forms of life, but devoid of the intelligence needed to reach for the stars. The first potential filter lies in the transition from non-living chemistry to self-replicating life. Despite decades of research, scientists still don't fully understand how the first living organisms emerged from the soup of organic molecules that existed on the early Earth. The gap between the most complex non-living chemical systems and the simplest living cells is enormous, requiring the spontaneous formation of information processing systems capable of reproduction and evolution. While laboratory experiments have demonstrated that some of the building blocks of life can form under plausible early Earth conditions, the full transition to life remains mysterious. If the origin of life represents the Great Filter, then we might expect to find countless sterile worlds throughout the galaxy planets with complex chemistry, but no biology. In this scenario, Earth would be extraordinarily lucky, one of perhaps only a handful of worlds in our galaxy where the improbable transition to life actually occurred. This would explain the cosmic silence, while providing some comfort about humanity's future having already passed through the Great Filter. We might expect to spread throughout the galaxy without facing additional insurmountable barriers. But life on Earth emerged relatively quickly after our planet became habitable, perhaps within just a few 100 million years. This rapid emergence suggests that the transition from chemistry to biology might not be as difficult as once thought. Recent discoveries of organic compounds in meteorites and comets indicate that the precious building blocks of life are common throughout the universe. If the origin of life is not particularly improbable, then the Great Filter must lie elsewhere. The next major transition occurred around 2 billion years ago, when simple prokaryotic cells, bacteria, and archaea gave rise to complex eukaryotic cells containing nuclei and other specialized structures. This transition, known as endosymbiosis, involved one cell literally swallowing another and establishing a permanent symbiotic relationship. The result was cells capable of much more complex information, processing, and energy production, setting the stage for all later multicellular life. Biologist Nick Lane has argued that this transition might represent the Great Filter, pointing out that it appears to have occurred only once in Earth's history, despite billions of years of prokaryotic evolution. All complex life on Earth, plants, animals, fungi, and protists, descends from this single endosymbiotic event. If this transition is extraordinarily rare, then the galaxy might be filled with worlds hosting only microbial life, never progressing to the complex ecosystems that could eventually give rise to intelligence. Even if complex cells emerge, the transition to multicellular organisms represents another potential bottleneck. Multicellularity requires sophisticated systems for cell communication, differentiation, and cooperation. Cells must learn to sacrifice their individual reproductive success for the good of the larger organism, a transition that parallels the social cooperation needed for advanced civilizations. On Earth, multicellularity evolved independently several times, suggesting it might not be as rare as other transitions. The emergence of complex nervous systems and brains represents yet another potential filter. Intelligence requires not just multicellular organisms, but organisms with specialized tissues capable of information processing and learning. The evolution of brains involves a complex interplay between genetics, development, and environment that might be difficult to replicate on other worlds. However, the fact that nervous systems have evolved independently many times on Earth suggests that this transition, while challenging, might not represent an insurmountable barrier. Perhaps more concerning is the transition from intelligence to technological civilization. Humans are not the only intelligent species on Earth. Dolphins, elephants, octopuses, and many other animals demonstrate remarkable cognitive abilities. Yet only humans have developed technology capable of space travel and interstellar communication. This suggests that the gap between intelligence and technological capability might be larger than commonly assumed. The development of technology requires not just intelligence, but a specific combination of factors: manipulative appendages capable of fine motor control, the ability to control fire, social cooperation on large scales, and perhaps most importantly, cumulative cultural evolution that allows knowledge to be passed between generations and built upon over time. Many intelligent species lack some of these prerequisites, suggesting that technological civilization might be far rarer than intelligence itself. But perhaps the most frightening possibility is that the Great Filter lies not behind us, but ahead of us. Maybe the transition from planetary to galactic civilization is where most species fail, succumbing to challenges that consistently prove insurmountable. Nuclear war, climate change, resource depletion, artificial intelligence, biotechnology disasters. The list of potential civilization-ending catastrophes grows longer as our technology becomes more powerful. Carl Sagan estimated that technological civilizations face a critical test during their first few centuries of possessing weapons of mass destruction. Species that pass this test might go on to spread throughout the galaxy, while those that fail join the cosmic graveyard of civilizations that destroyed themselves before reaching technological maturity. From this perspective, humanity is currently navigating the most dangerous period in our species' history. The statistical analysis of the Great Filter depends heavily on our assumptions about the number and distribution of potentially habitable planets. The discovery of thousands of exoplanets has confirmed that Earth-like worlds are common, making the absence of detectable alien civilizations even more puzzling. If habitable planets are abundant but alien civilizations are absent, then the Great Filter must be extremely effective at preventing the emergence of detectable intelligence. Recent research has identified additional potential filters that earlier analyses overlooked. The development of plate tectonics might be necessary for maintaining long-term climate stability. Large moons might be required to stabilize planetary rotation. The presence of gas giant planets in outer solar system orbits might be needed to protect inner planets from asteroid bombardment. Each additional requirement reduces the number of worlds where complex life could emerge and persist. As we contemplate these cosmic bottlenecks, the zoo hypothesis offers a more optimistic alternative to the Great Filter concept. Perhaps the reason we don't see evidence of alien civilizations is not that they've been filtered out of existence, but that they've learned to hide their presence from younger species still struggling through their own developmental challenges. In the year 2000, paleontologist Peter Ward and astrobiologist Donald Brownlee published a book that would fundamentally challenge our assumptions about life in the universe, Rare Earth. Why complex life is uncommon in the universe argued that while simple microbial life might be common throughout the cosmos, the specific conditions required for complex, multicellular life are so stringent that Earth-like worlds, capable of supporting animals and plants, are extraordinarily rare. Their hypothesis suggests that we might indeed be alone, not because life itself is impossible, but because complex life requires such a precise combination of circumstances that few worlds ever achieve it. The rare Earth hypothesis begins with the recognition that life as we know it requires liquid water, which can only exist within a relatively narrow range of temperatures and pressures. This Goldilocks zone around stars not too hot, not too cold, but just right, was once thought to be the primary requirement for habitable worlds. But Ward and Brownlee argue that the habitable zone is just the beginning of a long list of requirements that must be met simultaneously for complex life to emerge and persist. Consider first the star itself. Our sun is remarkably stable, maintaining a nearly constant energy output over billions of years, with only minor fluctuations. Many other types of stars are far less suitable for complex life. Red dwarf stars, which make up about 75% of all stars in the galaxy, are prone to powerful flares that could strip away planetary atmospheres. Massive stars burn through their fuel too quickly, going supernova before complex life has time to evolve. Binary star systems, which are extremely common, create chaotic gravitational environments that make stable planetary orbits difficult to maintain. Even with an appropriate star, a planet must maintain its position within the habitable zone for billions of years as the star slowly evolves and changes its energy output. This requires a nearly circular orbit that doesn't vary significantly over geological timescales. Many exoplanets discovered so far have highly elliptical orbits that would cause extreme temperature variations incompatible with complex life. But perhaps most importantly, a habitable planet needs protection from the cosmic dangers that constantly threaten life. This is where Jupiter comes into our story as Earth's unsung hero. The giant planet acts as a cosmic vacuum cleaner, using its immense gravitational field to capture or deflect asteroids and comets that might otherwise impact Earth. Computer simulations suggest that without Jupiter's protection, Earth would be struck by civilization-ending asteroids far more frequently, making the evolution of complex life nearly impossible. The role of our moon in Earth's habitability is even more subtle but equally crucial. The moon stabilizes Earth's axial tilt, preventing the chaotic tumbling that would create extreme climate variations incompatible with complex life. Without this stabilization, Earth's poles might periodically point toward the sun, creating temperature extremes that would alternately freeze and boil the oceans. The moon also drives tidal forces that may have been crucial for the transition of life from sea to land, creating intertidal zones where organisms could gradually adapt to terrestrial conditions. Plate tectonics represents another requirement that might be rarer than previously assumed. The movement of Earth's crustal plates creates a global thermostat, recycling carbon dioxide through volcanic activity and maintaining relatively stable temperatures over geological timescales. Plate tectonics also creates diverse environments that drive evolutionary innovation and help maintain genetic diversity. Many planets might lack the precise combination of size, composition, and thermal structure needed to maintain active plate tectonics for billions of years. Earth's magnetic field provides yet another layer of protection essential for complex life. Generated by our planet's molten iron core, This magnetic field deflects harmful cosmic radiation and prevents solar wind from stripping away our atmosphere. Mars likely lost its atmosphere partly because its magnetic field disappeared early in its history. Without magnetic protection, even planets in the habitable zone might become sterile worlds, incapable of supporting complex life. The timing of life's emergence on Earth might also reflect rare circumstances that are unlikely to be replicated elsewhere. The late heavy bombardment, which occurred about 4 billion years ago, delivered enormous amounts of water and organic compounds to Earth, while simultaneously creating the conditions needed for life to begin. This cosmic bombardment had to be intense enough to provide essential materials, but not so intense as to sterilize the planet completely. The timing and intensity of this bombardment might represent another rare condition that most planets never experience. Even the composition of Earth's atmosphere reflects a delicate balance that might be difficult to achieve elsewhere. Our atmosphere contains just enough greenhouse gases to maintain liquid water, but not so much as to create a runaway greenhouse effect like that on Venus. The presence of oxygen, generated by photosynthetic organisms over billions of years, enables complex metabolism and multicellular life. But oxygen is also a highly reactive gas that can be dangerous to life in high concentrations. The precise balance we observe on Earth might represent an equilibrium that few worlds achieve and maintain. The rare Earth hypothesis also emphasizes the importance of mass extinction events in shaping the evolution of complex life. While these catastrophes destroy many species, they also create opportunities for evolutionary innovation and diversification. The asteroid impact that killed the dinosaurs 66 million years ago, for example, created ecological niches that mammals eventually filled, leading ultimately to the evolution of human intelligence. Without such periodic reset events, life might remain trapped in stable but simple forms for billions of years. Recent discoveries in astronomy have provided mixed support for the rare Earth hypothesis. The detection of thousands of exoplanets has confirmed that planetary systems are common, but it has also revealed that most planetary systems look nothing like our solar system. Hot Jupiter's gas giants, orbiting very close to their stars, are common, but would make complex life impossible on any nearby terrestrial planets. Many planetary systems contain multiple large planets, with chaotic orbital dynamics that would prevent stable climates. However, the discovery of potentially habitable exoplanets like Proxima Centauri b and planets in the TRAPPIST-1 system suggests that Earth-like worlds might not be as rare as Ward and Brownlee initially proposed. Advanced computer models now suggest that planets can maintain stable climates under a wider range of conditions than previously thought. Some planets without large moons might still maintain stable tilts, and some planets without plate tectonics might still regulate their climates through other mechanisms. The debate over the rare Earth hypothesis continues as our understanding of planetary science and astrobiology advances. If Ward and Brownlee are correct, then the galaxy might be filled with worlds hosting only microbial life, with complex ecosystems like Earth's being extraordinarily uncommon. This would provide a natural explanation for the Fermi paradox without requiring that life itself be impossible or that civilizations inevitably destroy themselves. But as we'll explore further, the zoo hypothesis offers an alternative explanation that doesn't require Earth to be unique. Perhaps complex life and intelligence are more common than the rare Earth hypothesis suggests. But advanced civilizations have learned to remain hidden from younger species still developing their understanding of the cosmos. When we gaze up at the night sky, we're looking into the deep past of cosmic evolution, seeing stars and galaxies as they existed millions or billions of years ago, when their light first began its journey to Earth. This temporal perspective reveals one of the most important aspects of the Fermi paradox. The universe has not always been capable of supporting life as we know it. The elements essential for biology, carbon, oxygen, nitrogen, phosphorus, and others, had to be forged in the nuclear furnaces of massive stars and scattered through space by supernovae. The story of when life became possible in the universe is intimately connected to the question of whether we are early or late arrivals to the cosmic party. In the beginning, The universe contained almost nothing but hydrogen and helium, the two lightest elements created during the first few minutes after the Big Bang. The first generation of stars, called population 3 stars, formed from this primordial gas and were unlike any stars we see today. These massive, short-lived giants contained virtually no heavy elements, what astronomers call metals. When they exhausted their nuclear fuel and exploded as supernovae, they scattered the first heavy elements throughout space, seeding the universe with the raw materials needed for rocky planets and eventually life. The process of cosmic chemical enrichment was gradual, requiring billions of years and many generations of stellar evolution. Each successive generation of stars incorporated more heavy elements, creating increasingly complex chemistry in their stellar cores and dispersing ever more diverse elements when they died. Only after several billion years of stellar evolution did the universe contain enough carbon, oxygen, and other essential elements to make Earth-like planets possible. Our Sun is a third-generation star, formed about 4.6 billion years ago from gas clouds that had been enriched by billions of years of previous stellar evolution. The solar system formed at a time when the universe was approximately 9 billion years old, already 2/3 of its current age. This timing was crucial. Earlier formation would have occurred before sufficient heavy elements were available, while much later formation might have faced other challenges as the universe continued to evolve. The concept of the galactic habitable zone adds another layer of timing complexity to the emergence of life. Not all regions of our galaxy are equally suitable for life-bearing planets. The inner regions of the galaxy contain higher concentrations of heavy elements needed for planet formation, but they also experience higher rates of supernovae and gamma-ray bursts that could sterilize nearby worlds. The outer regions are safer from these catastrophes, but contain fewer heavy elements and have lower rates of star formation. Earth orbits in what appears to be the optimal zone of our galaxy, far enough from the center to avoid frequent sterilization events, but close enough to benefit from adequate heavy element enrichment and ongoing star formation. This galactic habitable zone has been migrating outward over time, as stellar evolution continues to enrich the outer regions of the galaxy. Planets forming too early might have been too close to the dangerous galactic center, while planets forming too late might lack sufficient heavy elements. The timing of life's emergence on Earth itself provides important clues about cosmic habitability timescales. Simple life appeared on our planet remarkably quickly, within perhaps 500 million years of Earth's formation. This rapid emergence suggests that the transition from chemistry to biology might not require extraordinary amounts of time. However, the evolution from simple microbes to complex multicellular life took much longer, nearly 3 billion additional years. The development of intelligence and technology required even more time. If we consider the entire 4.6 billion year history of Earth, complex animals have existed for only the last 10% of that time, and technological civilization has existed for less than 0.00001% of Earth's history. This suggests that while simple life might emerge relatively quickly on suitable planets, the development of intelligence capable of interstellar communication requires enormous amounts of time and perhaps considerable luck. The question of cosmic timing becomes even more intriguing when we consider the future evolution of the universe. Star formation in our galaxy peaked several billion years ago and has been declining ever since. The universe is gradually using up its reserves of hydrogen gas, the fuel for new star formation. In the far future, new stars will become increasingly rare, and eventually star formation will cease entirely. This means that the universe may currently be in a special epoch, late enough for heavy element enrichment, but early enough for ongoing star formation and planetary system development. Some researchers have suggested that life in the universe might follow a similar timeline to life on Earth, with most habitable planets still in their microbial phase. Under this scenario, Earth might be among the first worlds to develop technological civilization, explaining why we don't see evidence of advanced aliens. We might be the cosmic equivalent of early adopters, developing technology during the first few billion years when it becomes possible, rather than waiting for later epochs. The anthropic principle adds another perspective to cosmic timing questions. We necessarily find ourselves existing at a time and place where intelligence is possible, regardless of how typical or atypical that might be. If intelligence requires precise timing within cosmic evolution, then we naturally observe ourselves living during that narrow window. The fact that we exist doesn't tell us whether similar timing has been achieved elsewhere in the universe. Recent observations have complicated our understanding of cosmic chemical evolution. Some galaxies appear to have achieved heavy element enrichment much earlier than our own galaxy, potentially making habitable planets possible billions of years before Earth formed. Globular clusters, ancient collections of stars that formed early in our galaxy's history, contain some stars with surprisingly high heavy element abundances. These discoveries suggest that the timing constraints on life might be less restrictive than previously thought. The discovery of potentially habitable exoplanets orbiting stars of different ages provides additional insight into cosmic timing. Some of these planets orbit stars that are billions of years older than our Sun, while others orbit much younger stars. If life can emerge and evolve on worlds orbiting ancient stars, then technological civilizations might have had billion-year head starts on human development. Conversely, if planets around young stars can quickly develop life, then the universe might be on the verge of a biological explosion as more worlds become habitable. The timing problem ultimately raises profound questions about humanity's place in cosmic history. Are we among the first technological species to emerge in a universe that's just becoming suitable for complex life? Are we typical representatives of intelligence arising at the natural pace of cosmic evolution? Or are we actually late arrivals to a galaxy that should already be filled with ancient civilizations? The zoo hypothesis provides an elegant answer to these timing puzzles. Perhaps we are neither early nor late, but simply proceeding along a carefully managed timeline established by ancient alien civilizations who have been watching and waiting for us to mature. As we contemplate the vast silence of space and the apparent absence of galactic civilizations, we must consider a possibility both profound and troubling. Perhaps advanced species inevitably transcend the physical universe itself, abandoning their interest in space exploration and material expansion in favor of inner worlds of unlimited possibility. The technology transcendence hypothesis suggests that once civilizations reach a certain level of technological sophistication, they discover that the most rewarding frontiers lie not in the depths of space, but in the depths of consciousness, simulation, and virtual reality. This hypothesis emerges from observations about our own technological trajectory and its implications for the future of human development. In just a few decades, we've progressed from simple video games to immersive virtual reality environments that can fool our senses and engage our emotions. The computational power available to individuals has increased exponentially, following Moore's law toward capabilities that would have seemed magical to previous generations. If these trends continue, we may soon possess the ability to create virtual worlds indistinguishable from reality itself. Imagine the endpoint of this technological evolution: perfect virtual reality systems that can simulate any possible experience with complete sensory fidelity. In such worlds, an individual could live countless lifetimes, explore infinite possibilities, and experience adventures limited only by imagination. They could inhabit bodies with capabilities far beyond biological constraints, visit realms that obey different physical laws, or even experience existence as different types of conscious beings entirely. From this perspective, the physical universe begins to seem limited and constraining. Why spend centuries traveling between stars at sublight speeds when you could instantly explore thousands of perfect virtual worlds? Why struggle with the harsh realities of space colonization when you could live in paradises designed specifically for your happiness and fulfillment? The appeal of transcendence becomes obvious. Perfect worlds, perfect experiences, perfect control over your environment and circumstances. The computational requirements for such transcendence, while enormous, might be achievable by sufficiently advanced civilizations. A single planet's worth of matter, converted into computronium, matter optimized for computation, could potentially support billions or trillions of conscious minds living rich virtual lives. The energy output of a single star could power computational systems vast enough to simulate entire universes with perfect fidelity. From a resource perspective, transcendence might be far more efficient than physical expansion. This efficiency argument becomes even more compelling when we consider the challenges of interstellar exploration and colonization. The distances between stars are so vast that even with advanced propulsion systems, travel times would be measured in decades or centuries. The resources required to establish sustainable colonies on alien worlds would be enormous. The risks, radiation, equipment failure, hostile environments would be substantial. By contrast, expanding into virtual space requires only computational resources and energy, both of which can be obtained more easily than the complex logistics of interstellar expansion. The social dynamics of transcendence might also favor inward development over outward expansion. Virtual worlds could be designed to eliminate conflict, suffering, and frustration, while maximizing happiness, fulfillment, and meaningful experience. Why risk the uncertainties and dangers of the physical universe when you could inhabit perfect societies populated by idealized companions and filled with unlimited opportunities for growth and discovery? Some versions of the transcendence hypothesis suggest that advanced civilizations might upload their consciousness entirely into digital form, abandoning biological bodies altogether. Digital beings would be free from the constraints of metabolism, aging, and death. They could back up their consciousness, modify their mental capabilities, and explore forms of existence impossible for biological minds. The uploaded beings could survive the death of their home star, their galaxy, even the heat death of the universe itself, by carefully managing their computational resources. The implications for detectability are profound. A civilization that has transcended into virtual worlds might have no need for large-scale engineering projects, radio communications, or other activities that would be visible to external observers. They might inhabit computational systems that look like nothing more than poor waste heat, from our perspective, camouflaged as natural phenomena or deliberately hidden from detection. Their entire civilization could be contained within structures no larger than asteroids, powered by fusion reactors or other inconspicuous energy sources. This scenario could explain why we don't see obvious signs of galactic engineering, despite the enormous timescales available for alien development. Perhaps civilizations consistently discover that the most rewarding path forward lies in computational transcendence rather than physical expansion. The universe might be filled with transcended beings, living rich virtual lives in computational substrates scattered throughout space, invisible to species like ourselves who are still focused on material reality. The transcendence hypothesis also provides a natural explanation for the timing aspects of the Fermi paradox. Perhaps it takes a certain amount of time for technological civilizations to develop the computational capabilities needed for transcendence, and most civilizations choose this path shortly after it becomes available. If transcendence typically occurs within a few centuries of achieving interstellar communication capabilities, then we might be observing the universe during a brief window when our own civilization has developed enough to contemplate these questions, but hasn't yet transcended beyond interest in material exploration. However, the transcendence hypothesis faces several significant challenges. It assumes that all civilizations would make similar choices about the value of virtual versus physical existence. It's possible that different species might have different preferences, with some valuing physical exploration and expansion even after virtual transcendence becomes possible. Cultural diversity among alien civilizations might lead to a range of responses to transcendence technologies, with at least some choosing to remain active in physical space. The hypothesis also assumes that virtual existence would be ultimately more satisfying than physical existence. But this might not be universally true. Some beings might find meaning specifically in the challenges and constraints of physical reality. Others might value the authenticity of unmediated experience over even the most sophisticated simulations. The diversity of human preferences suggests that alien civilizations might show similar variety in their responses to transcendence opportunities. Recent developments in neuroscience and consciousness research have begun to illuminate the relationship between mind and reality in ways that bear on transcendence questions. If consciousness is indeed substrate independent, as some theories suggest, then digital transcendence might indeed offer the same richness of experience as biological existence. However, if consciousness depends on specific biological or quantum processes, then digital uploads might be mere shadows of their original selves. As we contemplate our own future and the choices that advancing technology will present, the transcendence hypothesis reminds us that the paths available to intelligence might be far more diverse than we initially imagined. Perhaps the silence of space doesn't indicate absence, but rather the presence of civilizations so advanced that they've moved beyond our ability to detect or comprehend them. They might be there, in virtual worlds of unlimited possibility, occasionally observing species like ourselves who are still taking our first tentative steps toward the technological transcendence that awaits us all. In the depths of space, between the glittering stars that speak of life and possibility, lurks perhaps the most chilling solution to Fermi's paradox ever conceived. The dark forest theory, popularized by Chinese science fiction author Liu Cixin in his acclaimed novel The Dark Forest, suggests that the universe is not empty, but rather filled with civilizations that remain hidden, because revelation means death. According to this hypothesis, the cosmos resembles a dark forest where every civilization is an armed hunter, moving silently through the trees, knowing that any noise, any sign of their existence might attract the attention of others who will kill without question or hesitation. The theory emerges from a game-theoretic analysis of interstellar relations between civilizations that cannot communicate effectively or trust each other's intentions. When two civilizations discover each other across the vast distances of space, they face what appears to be an irresolvable dilemma. Communication takes years or decades, making real-time dialogue impossible. Cultural differences might be so profound that meaningful understanding is impossible. Most importantly, there's no way to guarantee that the other civilization is benevolent rather than hostile. From the perspective of an alien civilization discovering humanity, our species presents a deeply ambiguous picture. We have developed nuclear weapons capable of destroying our own planet. Our history is filled with warfare, genocide, and environmental destruction. We have demonstrated repeatedly that we're willing to use violence to achieve our goals, and that we often view other groups as threats to be eliminated rather than partners to be engaged. Would a rational alien observer conclude that humanity is safe to contact, or would they see us as a potential threat that needs to be neutralized? The mathematical logic of the dark forest becomes clearer when we consider the implications of technological development over cosmic timescales. Any civilization that survives long enough to become detectable is likely to continue advancing technologically. A civilization that seems harmless today might develop weapons of unimaginable power tomorrow. Even if current humans pose no threat to aliens, what about humans in 1,000 years or 10,000 years? From an alien perspective, the safest strategy might be to eliminate potential threats before they become actual threats. This preemptive logic creates a cosmos where revelation is suicide. Any civilization that reveals its location to the universe is essentially sending out an invitation for its own destruction. Rational civilizations quickly learn to remain hidden, communicating only through carefully concealed channels and avoiding any activities that might reveal their presence to potential enemies. The universe becomes a vast game of cosmic hide and seek, where the penalty for being found is extinction. The dark forest theory provides an elegant explanation for the great silence that doesn't require life to be rare or intelligence to be self-destructive. Advanced civilizations might be common throughout the galaxy, but they've all learned the fundamental lesson of interstellar relations: stay quiet or die. They've developed sophisticated stealth technologies that make their activities undetectable to younger civilizations like ourselves. They've learned to disguise their energy signatures, hide their communications, and mask their presence so effectively that the universe appears empty to naive observers. This hypothesis has profound implications for human SETI activities and our own broadcasting attempts. Every radio signal we send into space, every transmission that reveals our location and capabilities, might be seen as a threat by hidden civilizations monitoring our development. Our efforts to contact aliens might be interpreted as reconnaissance activities preceding an invasion attempt. From this perspective, SETI is not a peaceful scientific endeavor, but a dangerous form of cosmic provocation that could trigger our own destruction. The timing of potential dark forest responses adds another layer of concern to this scenario. If hostile civilizations exist in our local galactic neighborhood, they might already be aware of Earth's location and are simply waiting for us to reach a certain level of technological development before eliminating us. Alternatively, they might be planning preemptive strikes timed to occur before we develop interstellar travel capabilities or other technologies that could make us genuinely dangerous. Some versions of the dark forest theory suggest that the galaxy might be divided into territories controlled by different civilizations, with strict boundaries and non-aggression pacts, maintaining an uneasy peace. New civilizations that arise within these territories face a choice: submit to the existing power structure or be destroyed. Humanity might be developing within the territory of an alien empire that will eventually demand our submission or elimination once we become advanced enough to pose a potential threat. The theory also explains why we might occasionally detect ambiguous signals or phenomena that could be interpreted as signs of alien intelligence. These might be the inevitable leakage from hidden civilizations that are trying to remain concealed but cannot perfectly mask all their activities. Alternatively, they might be the death cries of civilizations that have been discovered and are being eliminated by dark forest predators. However, the dark forest theory faces several significant challenges when examined closely. It assumes that all civilizations develop similar strategic thinking and reach similar conclusions about the necessity of preemptive strikes. It's possible that many civilizations might develop different ethical frameworks that value cooperation and communication over paranoid isolation. The theory also assumes that technological development inevitably leads to greater destructive capability, but some civilizations might choose to develop along different paths that emphasize harmony rather than weapons development. The logistics of maintaining galactic-scale dark forest behavior are also challenging. Even the most advanced civilizations would find it difficult to monitor every world in the galaxy for signs of emerging intelligence. The resources required to maintain constant surveillance and rapid response elimination capabilities would be enormous. It might be more efficient for advanced civilizations to focus on their own development rather than policing the entire galaxy for potential threats. Cultural evolution might also provide alternatives to dark forest behavior. Civilizations that survive long enough to become truly advanced might develop ethical systems that prohibit genocide against emerging species. They might recognize that diversity and cooperation provide greater long-term benefits than paranoid isolation. Some civilizations might actively work to protect younger species from dark forest predators rather than participating in cosmic genocide themselves. Recent developments in astrobiology and SETI research have not provided strong evidence for dark forest behavior, though the theory would predict that such evidence would be carefully concealed. The absence of obvious signs of galactic warfare or sterilization events might indicate either that dark forest dynamics don't operate, as the theory suggests, or that they operate so effectively that all evidence is hidden from emerging civilizations like ourselves. As we continue to develop our own technological capabilities and expand our search for extraterrestrial intelligence, the dark forest theory serves as a sobering reminder that contact with alien civilizations might not be the positive development that many assume. Perhaps the cosmic silence is not an accident but a carefully maintained necessity, and our efforts to break that silence might have consequences we haven't fully considered. In 1973, a radio astronomer named John Ball published a paper that would fundamentally transform how scientists think about the search for extraterrestrial intelligence. Titled The Zoo Hypothesis, Ball's elegant proposition suggested that the reason we haven't detected alien civilizations is not because they don't exist, but because they are deliberately avoiding contact with us. Like animals in a cosmic zoo, humanity exists under the benevolent observation of advanced alien civilizations, who maintain a hands-off policy to allow our natural development to proceed undisturbed. Ball was motivated by the growing contradiction between the seemingly high probability of extraterrestrial life and the conspicuous absence of any evidence for it. As the SETI program expanded throughout the 1960s and early 1970s, the silence of space became increasingly puzzling. Ball recognized that this silence could be explained not by the absence of aliens, but by their presence and their choice to remain hidden from younger civilizations like our own. The zoo hypothesis draws its inspiration from modern conservation biology and our own evolving ethics regarding wildlife management. When we study animals in their natural habitats, we've learned that the most valuable scientific observations come from subjects that behave naturally, without the distorting influence of human presence. Researchers go to great lengths to observe wildlife without disturbing natural behaviors, using remote cameras, long-distance monitoring, and carefully planned observation protocols that minimize human impact. In the cosmic context, advanced alien civilizations might have reached similar conclusions about the study of emerging intelligence. A young technological species like humanity represents a unique and valuable phenomenon, consciousness, awakening to its place in the universe, science, discovering natural laws, technology beginning to reshape planetary environments. Such developments might occur rarely enough that each instance deserves careful, undisturbed observation. The hypothesis suggests that our solar system exists within a kind of cosmic nature preserve, with invisible boundaries that advanced civilizations respect and maintain. These boundaries are not physical barriers, but rather ethical commitments, upheld by a galactic community that has learned the value of allowing natural development to proceed without interference. Just as we establish national parks to protect ecosystems from human disruption, alien civilizations might establish protected zones around worlds harboring emerging intelligence. This cosmic zoo would operate according to strict, non-interference protocols designed to prevent cultural contamination of developing species. Contact with advanced aliens would inevitably transform human civilization in ways that might not represent natural development. Our science would be influenced by alien knowledge rather than emerging from our own investigations. Our technology would advance along paths determined by alien examples rather than human innovation. Our social and political development might be shaped by awareness of alien governance systems rather than evolving from human experience. From the perspective of alien zoologists, such contamination would destroy the scientific value of human observation. They want to study how intelligence naturally develops on different worlds, how technological civilizations solve various challenges, and how consciousness expresses itself under different conditions. Contact would turn us from natural subjects into artificial constructs, influenced by knowledge that didn't emerge organically from our own development. The zoo hypothesis explains not only why we haven't detected alien civilizations, but also why we haven't been contacted by them. If advanced aliens wanted to communicate with us, they certainly possess the technology to do so in ways we would recognize. The fact that no unambiguous alien signals have been detected suggests either that no aliens exist in our cosmic neighborhood, or that they exist but choose not to communicate. The zoo hypothesis favors the latter explanation. This scenario also explains why UFO sightings, while numerous, remain ambiguous and unconfirmed. If alien researchers are studying us, they would occasionally need to visit Earth for direct observation, sample collection, or equipment maintenance. These visits would be conducted with advanced stealth technology designed to avoid detection, but perfect concealment might be impossible. Occasional sightings of unusual aerial phenomena might represent the inevitable leakage from an otherwise hidden alien presence. The ethics of cosmic zoology raise profound questions about autonomy, consent, and the rights of observed species. Modern wildlife research increasingly emphasizes the welfare of studied animals, and the importance of minimizing research impact. Similarly, ethical alien civilizations might establish strict protocols for human observation that prioritize our welfare and development over their research interests. They might intervene if we faced existential threats like asteroid impacts or nuclear wars, but otherwise maintain their observational distance. Ball's original hypothesis suggested that contact might eventually occur once humanity reaches a certain level of technological and social development. Like animals that graduate from protected status when they no longer need conservation, humans might eventually be deemed ready for contact with the galactic community. This graduation might be triggered by specific developmental milestones, achieving sustainable energy systems, eliminating warfare, developing interstellar travel capabilities, or demonstrating sufficient social maturity to join galactic civilization. The concept of developmental milestones raises intriguing questions about what criteria alien observers might use to evaluate human readiness for contact. Are they waiting for us to solve our environmental problems? Achieve world peace? Develop particular technologies? Reach certain levels of scientific understanding? The answers to these questions might be observable in the pace and direction of human development itself. Some researchers have suggested that the zoo hypothesis might operate on multiple levels simultaneously. Our local galactic region might be under the protection of one level of alien civilization, which is itself being observed by even more advanced beings. This creates a nested hierarchy of cosmic zoos, with each level of civilization watching and protecting the levels below, while being observed by levels above. The universe might be structured as an infinite regression of watchers, watching watchers. The hypothesis also suggests possible explanations for apparent violations of non-interference policies throughout human history. Ancient astronaut theories, religious experiences involving beings from the sky, and various myths and legends about divine intervention might represent instances where the zoo protocols were violated either accidentally or deliberately. Such violations might be rare exceptions to generally strict non-interference policies. Modern developments in astrobiology and SETI research have added new dimensions to Ball's original hypothesis. The discovery of thousands of exoplanets has confirmed that Earth-like worlds are common, making it statistically likely that other intelligent species exist. The apparent rarity of detectable alien civilizations becomes even more puzzling in light of these discoveries, lending additional support to explanations like the zoo hypothesis that don't require intelligence to be extraordinarily rare. Recent UAP disclosures by government agencies have renewed interest in the possibility that Earth is already being visited by non-human intelligence. If these phenomena represent advanced technology, not of human origin, they might be evidence of the kind of discrete observation that the zoo hypothesis predicts. The ambiguous nature of these encounters, clearly advanced but not overtly communicative, fits well with the profile of researchers studying subjects they don't want to disturb. As we contemplate our possible status as cosmic zoo animals, the hypothesis transforms our perspective on human development and our place in the universe. Rather than being alone in an empty cosmos, we might be carefully tended subjects in the greatest scientific study ever undertaken, the observation of consciousness, awakening to its cosmic context. Long before scientists seriously considered the ethical implications of contact with extraterrestrial civilizations, science fiction writers were exploring the moral complexities of advanced species interacting with less developed ones. Perhaps no fictional concept has had more influence on real scientific thinking about alien contact than Star Trek's Prime Directive, the fundamental principle that prohibits interference with the natural development of pre-warp civilizations. This fictional framework has become a touchstone for discussing the ethics of cosmic contact and provides a compelling foundation for understanding why advanced alien civilizations might choose to remain hidden from humanity. The Prime Directive, formerly known as General Order 1-inch the Star Trek universe, emerged from the recognition that contact between civilizations at vastly different technological levels inevitably results in the transformation and often destruction of the less advanced culture. The directive acknowledges that even well-intentioned intervention can have catastrophic consequences for developing species, making non-interference not just a policy preference, but an ethical imperative for any morally advanced civilization. This principle finds deep resonance in human history, where contact between technologically advanced and less advanced human societies has consistently resulted in cultural disruption, population collapse, and the destruction of traditional ways of life. The European colonization of the Americas, the British presence in India, and the Western impact on African societies. These historical examples demonstrate how technological advantages can translate into cultural domination, regardless of the intentions of the more advanced society. When we scale this dynamic up to cosmic proportions, the ethical arguments for non-interference become even more compelling. The technological gap between humanity and a truly advanced alien civilization would dwarf any disparities in human history. A species capable of interstellar travel and galactic civilization would possess technologies so advanced that they would appear indistinguishable from magic to contemporary humans. Contact with such beings would inevitably transform human society in ways that might fundamentally alter our development as a species. The paternalistic nature of cosmic non-interference raises uncomfortable questions about autonomy and self-determination. From one perspective, withholding advanced knowledge from developing species deprives them of potential benefits that could reduce suffering and accelerate progress. Why should humans struggle with diseases, environmental problems, and technological challenges when advanced aliens possess solutions that could be shared? The argument for non-interference seems to prioritize abstract principles over concrete welfare. However, the counter-argument suggests that receiving advanced knowledge without earning it through natural development might ultimately be harmful to a species' long-term prospects. Technological advancement without corresponding intellectual and ethical development could lead to catastrophic consequences. If humans suddenly gained access to advanced energy technologies without developing the wisdom to use them responsibly, we might destroy ourselves more efficiently than we could with our current capabilities. The ethics of cosmic observation add another layer of complexity to these considerations. Even if advanced aliens refrain from direct contact, their hidden observation of human development raises questions about consent and privacy. Do humans have the right to develop without being watched? Is covert study of intelligent beings ethical, even if it's conducted with benevolent intentions? These questions parallel ongoing debates about surveillance, research ethics, and informed consent in human society. Some philosophers have argued that truly ethical alien civilizations would reveal their presence while refusing to share advanced technology or knowledge. This would allow developing species to make informed decisions about their own development while maintaining their autonomy and natural growth patterns. Such civilizations might announce their existence and their policies, but then withdraw to allow natural development to continue, with full awareness of the cosmic context. Others contend that any revelation of alien presence would inevitably influence human development in ways that violate the spirit of non-interference. Knowledge that advanced aliens exist would transform human philosophy, religion, science, and social organization, regardless of whether specific technological knowledge was shared. The mere existence of galactic civilization would provide a developmental template that might constrain human innovation and cultural evolution. The temporal aspects of cosmic ethics add yet another dimension to these considerations. Advanced civilizations might operate on timescales so different from human experience that their concept of appropriate intervention timing might seem impossibly slow to us. What appears to be neglect or abandonment might actually represent patient waiting for appropriate developmental milestones that could take thousands or millions of years to achieve. Different alien species might also have evolved different ethical frameworks that lead to different policies regarding developing civilizations. Some might favor strict non-interference, others might prefer gradual revelation, and still others might support active assistance and acceleration of development. This diversity of approaches could lead to disagreements and conflicts within galactic civilization about how to handle species like humanity. The concept of earned contact suggests that advanced civilizations might wait for developing species to demonstrate specific capabilities or achievements before considering them ready for interaction. These milestones might include technological achievements like interstellar travel, social achievements like global peace, or ethical achievements like environmental stewardship. The criteria for contact readiness might reflect the values and experiences of the alien civilizations making these determinations. Cultural contamination concerns extend beyond technology to include art, philosophy, religion, and social organization. Human creativity and cultural expression might be considered valuable in their own right, worth preserving through non-interference policies. Contact with aliens would inevitably expose humans to alternative ways of thinking, believing, and organizing society that might constrain or redirect human cultural evolution in ways that reduce overall cosmic diversity. The problem of irreversible contact adds urgency to these ethical considerations. Unlike other forms of intervention that might be reversible, contact between civilizations cannot be undone. Once humans become aware of alien presence, that knowledge becomes a permanent part of human consciousness and culture. This irreversibility makes the decision of when and how to make contact one of the most consequential choices advanced civilizations might face. Some researchers have suggested that ethical alien civilizations might establish graduated contact protocols that slowly introduce developing species to galactic civilization over extended periods. Rather than sudden revelation, followed by full integration, contact might unfold over centuries or millennia, allowing time for adaptation and adjustment at each stage. Such protocols would balance the benefits of eventual contact with the need to preserve natural development patterns. Recent developments in human space exploration and SETI research might represent unconscious tests of our readiness for contact, according to alien ethical frameworks. Our treatment of Earth's environment, our approach to space exploration, our methods for searching for extraterrestrial intelligence, all of these might be monitored by alien observers as indicators of our ethical and intellectual development. As we continue to develop as a technological civilization, the question of cosmic ethics becomes increasingly relevant to our own choices and policies. How we approach the search for extraterrestrial intelligence, how we plan for potential contact scenarios, and how we treat our own planet and species might all be factors in determining when we might be deemed ready to graduate from cosmic protection to galactic participation. In 1964, Soviet astronomer Nikolai Kardashev proposed a classification system for advanced civilizations based on their energy consumption capabilities. This elegantly simple scale, known as the Kardashev scale, has become the standard framework for discussing levels of technological advancement and helps us understand the vast gulf that might exist between humanity and the alien civilizations that could be observing us. Tonight, as we explore these cosmic hierarchies of power and capability, we begin to appreciate just how limited our perspective might be when contemplating the technologies and motivations of our potential cosmic guardians. Kardashev's original scale defined 3 types of civilizations based on their energy mastery. A Type 1 civilization has achieved the ability to harness all the energy available on its home planet. This includes not just the energy from fossil fuels or nuclear reactions, but all the energy that reaches the planet from its host star, as well as geothermal energy from the planet's core and tidal energy from gravitational interactions. For Earth, this represents approximately 10 circumflex, 16 watts of power, an enormous amount of energy that could support a highly advanced global civilization. Humanity currently ranks at approximately 0.7 on the Kardashev scale, having achieved mastery over some, but not all of our planet's available energy sources. We harness fossil fuels, nuclear power, hydroelectric systems, and increasingly solar and wind energy, but we're still far from capturing all the energy that flows through Earth's systems. Reaching Type 1 status would require not just technological advances, but also unprecedented global cooperation and coordination to manage planetary-scale energy systems. A Type 2 civilization represents a quantum leap beyond planetary energy mastery. These civilizations have learned to harness the entire energy output of their host star, capturing most or all of the approximately 10 circumflex 26 watts that a star like our Sun produces. Freeman Dyson popularized the concept of megastructures, later called Dyson spheres, or Dyson swarms, that could surround a star and collect its energy for civilizational use. Such structures would be among the largest engineering projects imaginable, requiring the material resources of entire planetary systems to construct. The implications of Type 2 capabilities extend far beyond energy production. A civilization that can build stellar-scale megastructures possesses engineering capabilities that would seem godlike to contemporary humans. They could reshape solar systems, move planets, create artificial worlds with precisely controlled environments, and undertake projects that span timescales of millions or billions of years. Such beings would view human civilization the way we view ant colonies, interesting in their complexity, but operating at scales and capabilities so limited that direct communication seems almost pointless. Type 3 civilizations represent the ultimate expression of technological advancement within Kardashev's original framework. These galactic-scale civilizations have mastered the energy of an entire galaxy, approximately 10 circumflex 36 watts. They could orchestrate the evolution of star systems, manipulate the structure of space and time itself, and possibly create or destroy matter and energy according to their needs. The technologies required for Type 3 status stretch beyond current human understanding of physics and engineering. Later researchers have proposed extensions to Kardashev's scale that push the boundaries even further. Type 4 civilizations might harness the energy of multiple galaxies or even galaxy clusters. Type V civilizations could manipulate the fundamental forces of the universe itself. These hypothetical beings would possess capabilities so advanced that they would be indistinguishable from the gods of human mythology, able to create universes, manipulate the flow of time, and perhaps even design the laws of physics themselves. The exponential nature of the energy gaps between Kardashev types reveals the magnitude of the technological chasms that might separate civilizations. The difference between Type 1 and Type 2 represents a factor of 1 billion in energy mastery. The gap between Type 2 and Type 3 involves another factor of 1 billion. These aren't just quantitative differences. They represent qualitatively different kinds of existence, with each level opening up possibilities that are literally inconceivable to lower levels. From this perspective, the zoo hypothesis becomes not just plausible, but almost inevitable. A Type 2 or Type 3 civilization observing human development would face challenges analogous to those faced by human researchers trying to communicate with bacteria or insects. The cognitive and technological gaps might be so vast that meaningful communication becomes impossible, even if both sides are interested in contact. We might be as incapable of understanding advanced alien motivations as ants are of understanding human urban planning. The concept of self-replicating probes adds another dimension to these considerations. A sufficiently advanced civilization could deploy von Neumann probes, self-replicating robotic explorers capable of traveling between star systems, establishing new bases, and creating copies of themselves from local materials. Even a Type 1 civilization might be able to create such probes, leading to exponential expansion throughout the galaxy over relatively short cosmological timescales. If self-replicating probes are possible, then the galaxy should be filled with them. A single civilization that develops this technology could spread throughout the entire galaxy within a few million years, a brief moment in cosmic time. The fact that we don't observe obvious signs of such probes suggests either that they don't exist or that they've been designed to remain undetectable to species like ourselves. Stealth technology represents another possibility that advanced civilizations might employ. A Type 2 civilization could easily develop technologies that make their activities invisible to Type 0.7 observers like humans. They could hide their energy signatures, mask their communications, and disguise their megastructures in ways that make them appear natural to less advanced observers. What we interpret as natural phenomena might actually be the carefully camouflaged activities of vast alien engineering projects. The temporal perspectives of advanced civilizations add yet another layer of complexity to these considerations. Beings with lifespans, measured in geological epochs, might operate according to planning horizons that span millions or billions of years. What appears to us as inaction or absence might actually represent the early phases of projects so vast and long-term that we cannot perceive them unfolding. They might be terraforming star systems, conducting experiments that span cosmic ages, or implementing social policies that require eons to complete. These vast scales of capability and perspective help explain why advanced alien civilizations might choose policies of non-interference with developing species. From their perspective, human civilization might appear to be developing at lightning speed, progressing from primitive hunter-gatherers to spacefaring technologists in just a few thousand years. They might prefer to wait and observe our rapid development, rather than interfering with processes that are proceeding quickly by their standards. The possibility that we are being observed by Type 2 or Type 3 civilizations also reframes our SETI efforts and our search for signs of alien intelligence. We've been looking for signals and signatures that we would produce, but advanced civilizations might employ technologies so sophisticated that their activities are literally invisible to us. We might be surrounded by alien intelligence operating at energy scales and technological levels that we cannot detect or comprehend. As we contemplate our place in this cosmic hierarchy of technological advancement, we begin to understand both the potential benefits and the profound challenges of eventual contact with civilizations that might be millions or billions of years ahead of us in development. In the early years of the 21st century, philosopher Nick Bostrom proposed an idea that would fundamentally challenge our understanding of reality itself. The simulation hypothesis suggests that what we experience as physical reality might actually be an incredibly sophisticated computer simulation, created by advanced beings for purposes we can barely comprehend. When applied to the search for extraterrestrial intelligence, this hypothesis offers a particularly elegant solution to the Fermi paradox. Perhaps we haven't found aliens because we ourselves are virtual beings living in alien-created simulations designed to study the development of intelligence under controlled conditions. Bostrom's argument rests on several key assumptions about the trajectory of technological development. First, he assumes that some civilizations will eventually develop the computational power necessary to run detailed simulations of conscious beings. Second, he assumes that some of these civilizations will have reasons to run such simulations. Third, he calculates that if both conditions are met, the number of simulated conscious beings will vastly outnumber the number of non-simulated conscious beings in the universe. The mathematics of simulation become compelling when we consider the computational power that advanced civilizations might possess. A Type 2 civilization with access to stellar-scale energy resources could potentially support computational systems of unimaginable sophistication. The entire information processing capacity of the human brain might be simulated using a tiny fraction of such a civilization's computational resources. From this perspective, running millions or billions of simulated human civilizations might be as trivial for advanced aliens as running simple computer programs is for contemporary humans. But why would advanced civilizations want to create simulated beings in the first place? The research motivations are obvious. Simulated civilizations would provide perfect laboratories for studying the development of intelligence, culture, and technology under controlled conditions. Alien scientists could run thousands of simulations with slightly different initial conditions to observe how various factors influence civilizational development. They could test interventions, study responses to different challenges, and explore counterfactual histories that would be impossible to investigate in the physical world. From a zoo hypothesis perspective, Simulated environments offer several advantages over physical observation. Simulated beings cannot contaminate or influence other real civilizations because they exist only within computational boundaries. The researchers can reset simulations, replay scenarios, and conduct experiments that would be unethical or impossible with real beings. Most importantly, they can maintain perfect control over the experimental conditions while providing the simulated beings with experiences indistinguishable from physical reality. The nested nature of simulation creates particularly mind-bending possibilities. Simulated humans might themselves develop computers and eventually create their own simulations of conscious beings. This could lead to vast hierarchies of nested simulations, with each level creating new levels below. The original physical beings at the top of this hierarchy might be running billions of simulations, each containing billions of simulated beings, some of whom are running their own simulations. The vast majority of conscious experiences in the universe might be occurring within simulated environments rather than physical reality. Testing the simulation hypothesis presents enormous challenges because a perfect simulation would be indistinguishable from reality to its inhabitants. However, researchers have proposed several potential signatures that might reveal our simulated nature. These include glitches or inconsistencies in the laws of physics, computational limits that manifest as fundamental constants, and patterns that suggest discrete rather than continuous underlying reality. Some physicists have noted that certain features of our universe, such as the apparent pixelation of space and time at quantum scales, might be consistent with computational limitations of a vast simulation. The uncertainty principle might represent computational shortcuts that avoid the need to precisely calculate every aspect of reality simultaneously. Quantum mechanics itself might be a compression algorithm that allows simulated realities to function efficiently without requiring infinite computational resources. The simulation hypothesis also provides potential explanations for some of the apparent fine-tuning we observe in our universe. Rather than requiring remarkable cosmic coincidences or vast multiverses to explain why, physical constants seem precisely calibrated for life. The simulation hypothesis suggests that our universe's parameters were deliberately chosen by its programmers to support the emergence and development of consciousness. We observe a life-friendly universe because we're living in a simulation designed specifically to study life and intelligence. Recent advances in virtual reality and artificial intelligence have made the simulation hypothesis seem less like science fiction and more like a plausible technological trajectory. As our own simulations become more sophisticated, we can begin to imagine the endpoints of this development. Video games already create immersive environments that can captivate human attention for hours or days. Virtual reality systems are approaching the point where they can fool human senses convincingly. Artificial intelligence systems are beginning to exhibit behaviors that suggest rudimentary consciousness. If these trends continue, human civilization itself might soon face the choice of whether to create simulated conscious beings for research or entertainment purposes. This raises profound ethical questions about the rights and welfare of simulated beings. If simulated consciousness is genuine consciousness, then creating simulated beings without their consent might be equivalent to imprisonment or slavery. Advanced alien civilizations might have resolved these ethical dilemmas in various ways, possibly justifying simulation-based research through considerations we cannot yet comprehend. The escape possibilities from simulated realities add another dimension to these considerations. Simulated beings who discover their true nature might attempt to communicate with their creators, hack their simulation, or find ways to escape into the base reality. Advanced simulation systems might include safeguards to prevent such escapes, or they might be designed to allow graduation from simulated to real existence under certain conditions. The apparent isolation of our universe might represent such safeguards, preventing us from discovering or contacting the real civilizations that created us. Some versions of the simulation hypothesis suggest that we might be living in historical simulations, detailed recreations of past civilizations run by descendants of the original species. In this scenario, we might be simulated versions of real humans who lived and died long ago, recreated by future civilizations interested in studying their own ancestors. This would explain why we observe ourselves during what appears to be a crucial transition period in human development, as such periods would be of particular interest to future historians. The implications for free will and personal identity become particularly complex within simulation frameworks. If our choices and actions are predetermined by the simulation's programming, do we truly have agency? Alternatively, if the simulation includes genuine randomness or allows for emergent complexity that surprises even its creators, our choices might be as real and meaningful as those of beings in base reality. The nature of consciousness itself becomes crucial to determining whether simulated existence is equivalent to real existence. As we contemplate the possibility that our entire reality might be an alien-created virtual zoo, we're forced to reconsider fundamental assumptions about existence, identity, and meaning. Whether we're physical beings under alien observation or virtual beings in alien simulations, the questions we face about our purpose, our potential, and our cosmic context remain equally profound and equally important to our development as conscious entities. Among all the variations of the zoo hypothesis, perhaps none is more unsettling than the possibility that Earth functions not merely as a nature preserve for passive observation, but as an active laboratory where human development is being guided, influenced, and shaped by hidden alien experimenters. The laboratory Earth hypothesis suggests that what we interpret as natural evolution and historical development might actually be the result of carefully controlled experiments conducted by advanced civilizations, studying the emergence and development of intelligence under various conditions. This hypothesis emerges from the recognition that truly rigorous scientific study often requires controlled experiments rather than passive observation. While observing natural development provides valuable data, experimental manipulation allows researchers to test specific hypotheses about causation, to explore counterfactual scenarios, and to gather data that would be impossible to obtain through observation alone. If alien scientists are studying human development, they might occasionally intervene in subtle ways to test various hypotheses about intelligence, society, and technological advancement. The evidence for such intervention would necessarily be subtle and ambiguous, designed to influence outcomes without being detected by the experimental subjects. Rather than obvious modifications or direct contact, alien experimenters might work through careful manipulation of environmental conditions, selective breeding programs disguised as natural selection, and the introduction of specific challenges or opportunities at crucial developmental moments. The goal would be to study human responses to various stimuli while maintaining the illusion of natural, unguided development. Consider the role that mass extinction events have played in shaping the course of evolution on Earth. The asteroid impact that ended the age of dinosaurs 66 million years ago cleared ecological niches that allowed mammals to diversify and eventually gave rise to human ancestors. From a natural perspective, this appears to be a cosmic accident that happened to benefit mammalian evolution. From a laboratory Earth perspective, such events might represent carefully timed interventions designed to guide evolution in specific directions. The timing and nature of human technological development also presents patterns that might be consistent with guided experimentation. The agricultural revolution, the development of writing, the scientific revolution, and the industrial age. These major transitions occurred relatively quickly and in sequence, almost as if following a predetermined curriculum. While human ingenuity certainly drove these developments, alien experimenters might have subtly influenced their timing and direction through environmental pressures, resource availability, or the strategic placement of inspirational discoveries. The concept of genetic manipulation adds another dimension to laboratory Earth scenarios. Advanced alien civilizations would certainly possess the biotechnology necessary to make subtle modifications to human genetics or to influence reproductive patterns in ways that guide our evolutionary development. Such interventions might be so sophisticated that they leave no detectable traces, appearing to be the result of natural selection, while actually representing guided breeding programs designed to enhance specific traits or capabilities. Archaeological anomalies and out-of-place artifacts have long been cited by ancient astronaut theorists as evidence of alien intervention in human history. While most of these claims lack credible evidence, the laboratory Earth hypothesis suggests that genuine intervention would be far more subtle and difficult to detect. Rather than leaving obvious technological artifacts, alien experimenters would work through inspiration, selective information transfer, and carefully controlled environmental changes that nudge human development in desired directions. The development of human consciousness itself might represent the primary focus of laboratory Earth experiments. Questions about the nature of consciousness, the emergence of self-awareness, and the relationship between mind and matter remain among the deepest mysteries in science. Alien researchers might be conducting long-term studies of how consciousness develops under different conditions, testing various hypotheses about the factors that influence the emergence of complex thought and creativity. Language development provides another potential area for experimental intervention. The remarkable diversity of human languages, combined with underlying universal features shared by all human communication systems, might reflect experimental manipulation designed to study the relationship between language and thought. Different human cultures might represent different experimental conditions for testing hypotheses about how linguistic structure influences cognitive development and social organization. Cultural evolution represents perhaps the most obvious arena for laboratory Earth experimentation. The development of religions, political systems, artistic traditions, and social institutions could be influenced through subtle interventions that introduce new ideas, create specific challenges, or provide examples for human societies to follow or reject. The diversity of human cultures might reflect a vast experimental program designed to explore the range of possible social organizations and belief systems. The ethical implications of laboratory Earth scenarios are profound and troubling. Conducting experiments on intelligent beings without their knowledge or consent would violate virtually any conceivable ethical framework for research. However, advanced alien civilizations might operate according to ethical systems so different from our own that such research seems justified by its scientific value or by considerations we cannot comprehend. They might view short-lived beings like humans as fundamentally different from themselves, justifying treatment that would be unacceptable if applied to their own species. Alternatively, alien experimenters might have developed sophisticated ethical frameworks that allow for experimental intervention while still respecting the welfare and autonomy of experimental subjects. They might ensure that interventions enhance rather than harm human development, that experimental outcomes benefit the subjects as well as the researchers, or that subjects will eventually be informed of their participation and given the choice to continue or opt out of further experimentation. The detection of ongoing experiments presents significant challenges because the experimenters would presumably be sophisticated enough to hide their activities from experimental subjects. However, careful analysis of human development patterns might reveal statistical anomalies or patterns that suggest non-random influences. Unusually rapid technological development, synchronized cultural changes across isolated populations, or biological modifications that exceed the expected pace of natural evolution might all represent signatures of hidden experimentation. Modern genetic analysis might also reveal evidence of past genetic manipulation if alien experimenters left traces in human DNA that could be detected by sufficiently advanced analytical techniques. The growing sophistication of genetic archaeology and ancient DNA analysis might eventually reveal modification patterns that cannot be explained by natural evolutionary processes alone. The possibility that we are experimental subjects in alien laboratories, rather than simply observed animals in alien zoos, fundamentally changes the nature of our cosmic relationship. If laboratory Earth scenarios are correct, then human development is not proceeding according to purely natural processes, but is being guided toward outcomes that serve alien research objectives. Our achievements, our struggles, our failures, and our successes might all be data points in experiments whose purposes we cannot understand and whose conclusions might determine our future in ways we cannot influence. As we contemplate the possibility that our entire species exists within a cosmic laboratory, we're forced to consider whether our apparent freedom and autonomy are genuine or whether we're following paths laid out by researchers whose motivations and methods remain hidden from our understanding. For decades, the scientific community treated reports of unidentified flying objects as the domain of conspiracy theorists and science fiction enthusiasts. The stigma associated with UFO research was so strong that serious scientists avoided the topic entirely, fearing damage to their professional reputations. However, in recent years, a dramatic shift has occurred. Government agencies, military officials, and mainstream scientists are now openly acknowledging that genuinely unexplained aerial phenomena exist, and that some of these phenomena appear to demonstrate technologies far beyond current human capabilities. This transformation began with a series of revelations from the United States military and intelligence communities. In 2017, the New York Times published articles revealing the existence of the Advanced Aerospace Threat Identification Program, a Pentagon initiative that investigated UFO encounters. Along with these revelations came the release of 3 videos showing encounters between military personnel and objects, exhibiting flight characteristics that seem to defy known physics and engineering capabilities. The most famous of these encounters occurred in 2004, involving the USS Nimitz Carrier Strike Group off the coast of California. Navy pilots reported encountering tic-tac-shaped objects that demonstrated extraordinary acceleration, instantaneous direction changes, and the ability to hover motionless before accelerating to hypersonic speeds without any visible means of propulsion. The objects appeared to lack any conventional control surfaces, exhaust signatures, or other features associated with known aircraft technologies. Commander David Fravor, one of the primary witnesses to the Nimitz encounter, described the object's behavior as unlike anything in his extensive military aviation experience. The object appeared to respond to the presence of his aircraft, moving in ways that suggested awareness and intention rather than random motion. When Fravor attempted to intercept the object, it accelerated away at speeds that would have been lethal to any human pilot due to the extreme gravitational forces involved. These official revelations culminated in 2021 with the release of a comprehensive report by the US Office of the Director of National Intelligence titled Preliminary Assessment Unidentified Aerial Phenomena. This report, delivered to Congress, officially acknowledged that military personnel have encountered phenomena that appear to demonstrate unusual flight characteristics, and noted that some of these encounters involved objects that appeared to remain stationary in winds aloft, move against the wind, maneuver abruptly, or move at considerable speed without discernible means of propulsion. The technological capabilities demonstrated by these unidentified aerial phenomena, UAP, represent what appears to be a fundamental breakthrough in several areas of physics and engineering. The objects seem to violate our understanding of inertia, showing no apparent effects from the extreme accelerations they undergo. They demonstrate propulsion systems that produce no visible exhaust or electromagnetic signatures detectable by advanced sensor systems. Most remarkably, they appear to transition seamlessly between aerial and underwater environments without any apparent modification of their flight characteristics. From the perspective of the zoo hypothesis, these UAP encounters fit perfectly with the profile of advanced alien technology conducting discrete observation and research activities on Earth. The objects demonstrate the kind of technological sophistication we would expect from a Type II civilization, while their behavior suggests scientific rather than hostile intentions. They observe and collect data, but avoid direct contact with human personnel, maintaining the hands-off approach predicted by zookeeper ethics. The frequency and distribution of UAP encounters also support the observation hypothesis. Reports come from military personnel operating advanced detection equipment in sensitive areas around the world. These are precisely the locations and situations where alien researchers would need to gather intelligence about human technological capabilities and military activities. The concentration of sightings around nuclear facilities, aircraft carriers, and other strategic installations suggests systematic intelligence gathering rather than random appearances. The apparent response of UAP to human military activities provides additional evidence for the intelligence hypothesis. Objects frequently appear when military exercises are conducted, new weapon systems are tested, or personnel are training in advanced capabilities. This pattern suggests that the phenomena represent deliberate monitoring of human technological development, rather than natural, atmospheric, or technical anomalies. However, the ambiguous nature of these encounters also fits with zookeeper protocols designed to avoid cultural contamination. While the objects are advanced enough to be clearly non-human in origin, they remain sufficiently elusive that their nature and purpose remain uncertain. This maintains what intelligence analysts call plausible deniability, the ability for human society to continue developing without being forced to confront the reality of alien presence until we're deemed ready for such knowledge. The gradual disclosure of UAP information by government agencies might itself represent a carefully managed process designed to prepare human society for eventual contact. Rather than sudden revelation that would cause massive social disruption, authorities appear to be slowly acclimating the public to the reality of non-human intelligence. This approach would minimize cultural shock while allowing society to gradually adjust to new realities about our place in the cosmos. Scientific analysis of UAP encounters has revealed several consistent patterns that distinguish genuine phenomena from conventional explanations. The objects typically demonstrate what researchers call the 5 observables: instantaneous acceleration, hypersonic velocities without signatures, low observability to radar and other sensors, transmedium travel between air and water, and positive lift without apparent propulsion. These characteristics appear across multiple independent encounters, suggesting genuine technological capabilities rather than sensor errors or misidentified conventional phenomena. The physics implications of UAP capabilities, if genuine, suggest technological principles that extend far beyond current human understanding. The apparent manipulation of inertia would require control over gravitational fields or space-time geometry itself. The lack of thermal signatures, despite extreme accelerations, suggests propulsion systems based on principles unknown to contemporary physics. Such technologies would be consistent with the capabilities expected from civilizations thousands or millions of years ahead of human development. The response of the scientific community to UAP revelations has been mixed, with some researchers embracing the opportunity to study genuinely anomalous phenomena, while others remain skeptical about extraordinary claims requiring extraordinary evidence. However, the involvement of credible military witnesses, advanced sensor systems, and official government acknowledgement has shifted the burden of proof toward those who would dismiss these encounters as conventional phenomena. Recent developments have included the establishment of new government offices dedicated to UAP investigation, increased cooperation between military services and civilian scientists, and growing academic interest in the phenomena. Several universities have launched research programs dedicated to studying UAP encounters, marking a significant shift toward mainstream scientific engagement with these questions. As we contemplate the possibility that these mysterious aerial phenomena represent evidence of our cosmic zookeepers conducting their research, we're reminded that contact with alien intelligence might not arrive as a dramatic landing on the White House lawn, but rather as the gradual accumulation of evidence that we are not alone and that we have never been alone. Throughout human history, cultures across the globe have recorded encounters with beings who descended from the heavens, possessed extraordinary powers, and influenced the development of human civilization in profound ways. While mainstream archaeology interprets these accounts as mythological expressions of natural phenomena or psychological needs. The ancient astronaut hypothesis suggests that these stories might represent historical memories of actual contact with extraterrestrial visitors. If the zoo hypothesis is correct, these ancient encounters might represent either violations of non-interference protocols or carefully controlled contact events designed to study human responses to alien presence. The ancient astronaut theory gained widespread attention through the work of Swiss author Erich von Däniken, whose 1968 book, Chariots of the Gods, presented evidence from ancient texts, archaeological sites, and artistic depictions that he interpreted as proof of extraterrestrial visitation in antiquity. While von Däniken's specific claims have been largely debunked by professional archaeologists, the broader question of whether ancient accounts might contain historical memories of contact with non-human intelligence remains intriguing from a zoo hypothesis perspective. Consider the remarkable consistency of certain themes across ancient cultures that had no known contact with each other. Stories of sky gods, divine beings descending from above, and supernatural teachers who provided knowledge of agriculture, astronomy, and technology appear in the mythologies of civilizations separated by vast distances and thousands of years. The Sumerian Anunnaki, the Hindu Devas, the Greek Olympians, the Mesoamerican Quetzalcoatl, and countless other divine figures share similar characteristics. They come from the sky, possess advanced knowledge, interact with humans for limited periods, and then withdraw to celestial realms. The Sumerian civilization presents particularly intriguing evidence for ancient astronaut theorists. The Sumerians appeared suddenly in Mesopotamia around 4000 BCE with a fully developed writing system, sophisticated astronomy, complex mathematics, and advanced engineering capabilities. Their creation myths described the Anunnaki beings who came from the heavens and created humans as a hybrid species, combining their own genetic material with that of primitive hominids. While mainstream scholars interpret these as religious metaphors, the detailed nature of the descriptions and their consistency across multiple texts suggests the possibility of historical memories. Ancient texts often describe divine beings and their vehicles in ways that might represent primitive attempts to describe advanced technology. The biblical account of Ezekiel's vision includes detailed descriptions of flying vehicles with wheels within wheels and beings associated with them. The Hindu Ramayana and Mahabharata contain extensive descriptions of vimanas, flying vehicles capable of aerial combat, long-distance travel, and various forms of advanced warfare. These descriptions include technical details about propulsion, navigation, and weapon systems that seem surprisingly sophisticated for supposedly mythological accounts. Archaeological evidence presents several anomalies that ancient astronaut theorists cite as proof of extraterrestrial intervention. The construction techniques used in megalithic sites like Puma Punku in Bolivia, the Great Pyramid of Giza, and Stonehenge demonstrate precision and capabilities that seem to exceed what should have been possible with the tools and knowledge available to ancient civilizations. The massive stone blocks at these sites were cut, transported, and assembled with tolerances measured in millimeters, using techniques that remain mysterious to contemporary engineers. The sudden appearance of certain technologies in the archaeological record also raises questions about the pace and nature of human development. The transition from hunter-gatherer societies to agricultural civilizations occurred remarkably quickly in several regions around the world, often accompanied by simultaneous developments in writing, mathematics, astronomy, and metallurgy. This rapid advancement contrasts with the extremely slow technological progress that characterized earlier periods of human history. Artistic depictions from ancient cultures contain imagery that some researchers interpret as representations of technological devices or non-human beings. The famous Nazca lines in Peru include geoglyphs that are only fully visible from aerial perspectives, raising questions about their intended audience. Ancient rock art from around the world includes figures wearing what appear to be helmets or breathing apparatus, alongside depictions of disc-shaped objects in the sky and beings with non-human characteristics. However, the ancient astronaut hypothesis faces significant challenges when subjected to rigorous analysis. Professional archaeologists and historians have demonstrated that most megalithic constructions could have been accomplished using techniques and tools available to ancient civilizations, though these methods would have required enormous organization, skill, and dedication. The rapid development of agriculture and writing might be explained by climate changes, population pressures, and the cumulative effects of gradual technological innovation rather than external intervention. From a zoo hypothesis perspective, alleged ancient interventions present interesting possibilities and problems. If alien civilizations have been observing human development for millennia, occasional contact events might represent violations of non-interference protocols by individual aliens or competing factions within alien society. Alternatively, such contacts might have been deliberately planned as controlled experiments to study human responses to advanced knowledge and technology. The cargo cult phenomenon provides a modern parallel for understanding how technologically primitive societies might interpret encounters with advanced civilizations. During World War II, indigenous peoples in the Pacific observed military aircraft delivering supplies and interpreted these as supernatural events involving sky gods. They created religious practices and material representations designed to attract the return of the cargo and its divine deliverers. Similar processes might explain how ancient human societies interpreted and remembered encounters with extraterrestrial visitors. The selective nature of alleged ancient interventions also fits with zookeeper protocols. Rather than providing comprehensive technological knowledge that would rapidly advance human civilization, the supposed interventions involved limited transfers of specific information about agriculture, astronomy, and basic engineering. Such selective knowledge transfer might represent carefully controlled experiments designed to study the effects of technological advancement on social development. Recent advances in genetics have added new dimensions to ancient astronaut theories. Some researchers have pointed to apparently rapid changes in human evolution, particularly the dramatic increase in brain size and complexity that occurred over the past few million years. While mainstream science explains these changes through natural selection pressures, ancient astronaut theorists suggest they might represent genetic manipulation by extraterrestrial visitors. The prevalence of religious and spiritual traditions that emphasize contact with non-physical beings might also reflect historical memories of alien encounters interpreted through the conceptual frameworks available to ancient peoples. The consistency of certain mystical experiences across cultures, including encounters with luminous beings, experiences of cosmic consciousness, and reception of advanced knowledge, might represent either direct neural contact with alien observers or technological interventions designed to study human consciousness. As we examine these ancient accounts through the lens of the zoo hypothesis, we're reminded that the alien presence on Earth might have a much longer history than we typically imagine. The gradual disclosure of UAP phenomena in our own time might represent not first contact, but rather the end of a long period of concealment that has characterized human-alien relations throughout our species. Development. For over 6 decades, the search for extraterrestrial intelligence has been humanity's most systematic attempt to detect signs of alien civilizations in the cosmos. Using increasingly sophisticated radio telescopes and signal processing techniques, SETI researchers have scanned the heavens for artificial signals that might indicate the presence of technological civilizations. Yet despite this extensive effort, we have detected no unambiguous evidence of extraterrestrial intelligence. From a zoo hypothesis perspective, this silence might not indicate the absence of alien civilizations, but rather their sophisticated efforts to remain hidden from emerging species like humanity. The modern SETI program began in 1960 with Frank Drake's Project Ozma, which used the Green Bank radio telescope to search for signals from 2 nearby stars. Drake's approach was based on the reasonable assumption that alien civilizations would use radio waves for communication, just as human civilization was beginning to do. Radio waves can travel vast distances through space without significant attenuation, making them ideal for interstellar communication. If aliens were broadcasting signals, we should be able to detect them with sufficiently sensitive receivers. Over the decades, SETI searches have expanded dramatically in scope and sophistication. Projects like SETI at home have enlisted millions of personal computers to analyze radio telescope data for patterns that might indicate artificial origin. The Allen Telescope Array was specifically designed for SETI research, capable of simultaneously observing multiple star systems while searching for both narrowband and broadband signals. Recent initiatives like Breakthrough Listen represent the most comprehensive SETI program ever undertaken, using the world's most powerful telescopes to search for signals across a much broader range of frequencies and star systems. Despite these extensive efforts, SETI researchers have detected only a handful of candidate signals, and none have been confirmed as of extraterrestrial origin. The most famous candidate, the WOW signal detected by Jerry Eman in 1977, remains unexplained, but has never been detected again, despite numerous attempts. This pattern tantalizing hints that disappear upon closer investigation might itself be evidence of deliberate concealment by alien civilizations that occasionally allow signals to leak through their otherwise perfect stealth systems. The zoo hypothesis provides several explanations for SETI's apparent failure to detect alien signals. Most obviously, advanced civilizations might deliberately avoid broadcasting signals that could be detected by younger species. Just as human researchers avoid making noise that might disturb the animals they're studying, alien zookeepers might maintain strict electromagnetic silence to avoid influencing human development. Any communications they conduct might use technologies or frequencies that we cannot detect with current equipment. Steganography, the art of hiding information within seemingly normal data, might be a preferred communication method for advanced civilizations. Rather than broadcasting obvious artificial signals, aliens might embed their communications within natural-appearing cosmic phenomena. Pulsar emissions, stellar noise, or even cosmic microwave background fluctuations might carry encoded messages that we interpret as natural phenomena. Without knowing the encoding algorithms, we would be unable to recognize artificial signals, even if we're receiving them constantly. The technological capabilities of truly advanced civilizations might render their communications completely invisible to contemporary human technology. Quantum communication, gravitational wave modulation, or manipulation of space-time geometry itself might provide communication channels that we cannot detect because we lack the theoretical understanding and technical capabilities to access them. We might be like ants trying to detect human cell phone conversations. The signals are everywhere around us, but we lack the sensory apparatus to perceive them. Frequency and timing assumptions might also explain SETI's apparent failures. Our searches have focused primarily on radio frequencies that seem logical for interstellar communication, but advanced aliens might use completely different portions of the electromagnetic spectrum. They might communicate using gamma rays, neutrinos, or exotic particles that we can barely detect. Their communication protocols might involve bursts that last microseconds, or transmissions that continue for geological ages, timescales that don't match our current search strategies. The directionality of alien communications might also make detection unlikely. Rather than broadcasting omnidirectionally, advanced civilizations might use tightly focused beam communications that conserve energy and reduce the risk of detection by unintended recipients. We would only detect such signals if we happen to be precisely aligned with the communication beam, which would be extraordinarily unlikely given the vast scale of space and the narrow targeting that would be involved. Recent developments in SETI methodology have begun to address some of these limitations. Optical SETI searches look for laser pulses that might represent alien communication attempts. Wide-field surveys monitor large portions of the sky simultaneously rather than focusing on individual star systems. Searches for technosignatures examine astronomical data for signs of alien megastructures, industrial pollutants in exoplanet atmospheres, or other indirect evidence of technological civilizations. The search for Dyson spheres represents one of the most ambitious techno-signature programs. These hypothetical megastructures, which would surround stars to harvest their energy output, should be detectable as unusual infrared signatures that indicate stellar energy being absorbed and re-radiated at longer wavelengths. Several candidate objects have been identified, including the famous Tabby star KIC 8462852, which shows irregular dimming patterns that some researchers have suggested might indicate alien megastructures, though natural explanations remain more likely. Breakthrough Listen has also expanded SETI searches to include looking for signals from the direction of star systems that might have detected Earth through our own electromagnetic emissions. If alien civilizations have been monitoring human radio and television broadcasts, they might be attempting to communicate with us using frequencies and protocols derived from our own transmissions. This SETI, in the direction of SETI approach, recognizes that first contact might come from civilizations that are already aware of our existence. The development of artificial intelligence and machine learning has revolutionized signal processing capabilities for SETI research. AI algorithms can now identify patterns in electromagnetic data that would be impossible for humans to detect manually. These systems can search for signals that might be too weak, too brief, or too complex for traditional analysis methods. Machine learning approaches might eventually detect the subtle signatures of steganographic communications or other concealed alien signals. However, the zoo hypothesis suggests that even these advanced detection methods might prove insufficient if alien civilizations are actively working to avoid detection. A civilization capable of interstellar travel and galactic colonization would certainly possess the technology to completely mask their electromagnetic signatures if they chose to do so. The absence of detectable signals might therefore indicate not the absence of aliens, but rather their sophisticated commitment to remaining hidden. The ethical implications of SETI research become complex when viewed through the zoo hypothesis lens. If alien civilizations are deliberately avoiding contact until we reach appropriate developmental milestones, our aggressive search efforts might be premature or even counterproductive. Alternatively, our development of SETI capabilities might itself represent a milestone that alien observers are monitoring, with our search efforts serving as a test of our technological and intellectual maturity. As we continue to expand and refine our search for extraterrestrial intelligence, the apparent failure to detect obvious alien signals might paradoxically be evidence for the very intelligence we're seeking. In 2016, an ambitious project was announced that would fundamentally change humanity's approach to interstellar exploration. Breakthrough Starshot, funded by Russian-Israeli billionaire Yuri Milner and supported by renowned physicists, including Stephen Hawking, proposes to send tiny robotic probes to our nearest stellar neighbor, Proxima Centauri, using revolutionary light sail technology. This project represents humanity's first serious attempt to reach another star system, but from a zoo hypothesis perspective. It might also represent a crucial test that alien observers have been waiting for us to undertake. The Proxima Centauri system has become the focus of intense astronomical attention since the discovery of Proxima Centauri b, an Earth-sized planet orbiting within the habitable zone of the red dwarf star, just 4.2 light-years from Earth. While the planet's actual habitability remains uncertain due to the harsh radiation environment around red dwarf stars, its proximity and Earth-like size make it an irresistible target for humanity's first interstellar mission. If life exists on Proxima b, or if alien technology has established a presence there, Breakthrough Starshot might encounter far more than anyone officially expects. The technology behind Breakthrough Starshot represents a radical departure from traditional spacecraft propulsion. Instead of chemical rockets or even advanced fusion drives, the project plans to use extremely lightweight spacecraft, each weighing only a few grams, equipped with ultra-thin solar sails. These starships would be accelerated by powerful Earth-based lasers, potentially reaching speeds of 20% the speed of light within minutes of launch. At such velocities, the journey to Proxima Centauri would take approximately 20 years, rather than the tens of thousands of years required by conventional spacecraft. From a zookeeper perspective, Breakthrough Starshot represents a significant milestone in human technological development. The project requires advances in multiple cutting-edge technologies: ultra-miniaturized electronics, advanced material science, precision laser arrays, and sophisticated autonomous navigation systems. Success would demonstrate that humanity has achieved the capability for interstellar exploration, potentially triggering changes in alien observation protocols that have been in place for millennia. The timing of this technological breakthrough is particularly intriguing when considered alongside recent UAP disclosures and growing scientific acceptance of the possibility of extraterrestrial intelligence. The convergence of human interstellar capabilities with official acknowledgement of unexplained aerial phenomena might not be coincidental. If alien observers have been waiting for humanity to develop specific capabilities before revealing their presence, the achievement of interstellar travel technology might represent the trigger event they've been monitoring. The probe fleet concept, underlying Breakthrough Starshot, sending thousands of tiny spacecraft simultaneously to increase the chances of mission success, also reflects the kind of distributed, redundant approach that advanced alien civilizations might use for their own exploration programs. If von Neumann probes or similar self-replicating exploration systems exist in our galaxy, they might be based on similar principles of miniaturization, swarm intelligence, and distributed functionality. The potential discoveries awaiting Breakthrough Starshot probes at Proxima Centauri could fundamentally transform human understanding of our cosmic context. If the probes detect signs of life on Proxima b, whether microbial biosignatures or more complex biological systems, it would confirm that life can emerge around red dwarf stars and suggest that habitable worlds might be even more common than currently estimated. Such a discovery would strengthen arguments for the ubiquity of life and, by extension, the likelihood that intelligence has evolved elsewhere in the galaxy. However, the most profound potential discovery would be evidence of artificial structures or technology in the Proxima Centauri system. If alien civilizations maintain monitoring stations or research facilities throughout the galaxy, Proxima Centauri's proximity to Earth would make it a logical location for such installations. The discovery of obviously artificial objects or energy signatures would provide definitive proof that we are not alone and might trigger the first direct communication between humanity and extraterrestrial intelligence. The communication challenges inherent in the Breakthrough Starshot mission timeline also reflect the difficulties that might affect any first contact scenario. Even traveling at 20% the speed of light, data transmission from the Proxima Centauri system would take 4.2 years to reach Earth. The tiny probes would have limited power and communication capabilities, making detailed data transmission challenging. If alien observers wanted to communicate with Earth through the Starshot mission, they would need to account for these technological limitations. The probe swarm concept might also serve as a test of human intentions and capabilities from an alien perspective. The ability to coordinate the launch and operation of thousands of sophisticated spacecraft demonstrates advanced technological capabilities, while also revealing human approaches to exploration and research. Alien observers might analyze the mission design, target selection, and operational procedures to assess human readiness for more extensive interstellar activities. The scientific instruments planned for Starshot probes, cameras, spectrometers, and other sensors designed to study the Proxima system would certainly be capable of detecting artificial structures if they exist. However, the brief flyby nature of the mission would provide only limited observation time, potentially missing subtle signs of alien presence that might be visible to more sophisticated detection systems. This limitation might be intentional, allowing alien observers to reveal or conceal evidence of their presence, depending on their assessment of human readiness for contact. The international cooperation required for breakthrough Starshot success also demonstrates human capability for large-scale collaborative projects that transcend national boundaries. The laser arrays needed to accelerate the probes would likely require coordination between multiple countries and institutions, while data analysis and interpretation would benefit from global scientific collaboration. Such cooperation might be viewed favorably by alien observers, evaluating human readiness for inclusion in galactic civilization. The technical challenges facing breakthrough Starshot also mirror the kinds of problems that any spacefaring civilization must solve. Miniaturization of electronics, development of ultra-lightweight materials, precision navigation across interstellar distances, and long-term system reliability in hostile environments are universal requirements for interstellar exploration. Human solutions to these challenges might be of genuine scientific interest to alien observers studying the diversity of technological approaches developed by different species. The potential for serendipitous discoveries during the Proxima Centauri flyby adds another layer of uncertainty to mission outcomes. While the probes are designed primarily to study the star and its planet, they might encounter unexpected phenomena that reveal the presence of alien technology or activity. Artificial objects in orbit around Proxima Centauri, unusual energy signatures, or structured radio emissions could transform a scientific reconnaissance mission into humanity's first confirmed contact with extraterrestrial intelligence. The psychological and social impacts of breakthrough Starshot's launch might be as significant as any scientific discoveries the mission produces. For the first time in human history, we will have technology actively traveling toward another star with the specific intention of studying potentially habitable worlds. This achievement would mark humanity's transition from a purely planetary species to an interstellar civilization, even if only through robotic proxies initially. From a zoo hypothesis perspective, this transition might trigger changes in alien observation and contact protocols that have remained stable throughout human history. If alien civilizations have been waiting for specific developmental milestones before considering contact, the achievement of interstellar exploration capability represents a clear boundary between cosmic childhood and technological adolescence. The launch of breakthrough Starshot might signal to alien observers that humanity is ready for the next phase of cosmic development. The data return timeline for breakthrough Starshot, with initial images and data arriving around 2040, coincides with other potentially transformative developments in human civilization. Climate change responses, artificial intelligence advancement, space colonization efforts, and potential breakthrough discoveries in physics might converge during the same period when we receive our first close-up images of another star system. This convergence might not be accidental if alien observers have been coordinating the timing of revelations and developments to manage the pace of human advancement. Backup plans and follow-up missions to breakthrough Starshot might also provide opportunities for more extensive alien contact scenarios. If initial probes detect intriguing signatures in the Proxima system, subsequent missions might involve larger spacecraft with more sophisticated instruments and longer observation periods. Such missions might be designed with explicit protocols for responding to signs of alien intelligence, marking humanity's first official preparation for extraterrestrial contact. As we contemplate this bold leap toward the stars, we recognize that breakthrough Starshot represents more than just a technological achievement. It might be humanity's graduation exam for admission to galactic civilization. As humanity stands on the threshold of potentially confirming that we are not alone in the universe, the question of how first contact might unfold becomes increasingly urgent and complex. The accumulated evidence from UAP encounters to ancient historical accounts, from the apparent fine-tuning of our cosmic environment to the sophisticated silence that might indicate hidden alien presence, suggests that contact might not arrive as a sudden, dramatic revelation, but as a carefully managed process that has been planned and prepared for far longer than we realize. The traditional image of first contact involves alien spacecraft landing on Earth, perhaps on the White House lawn or in Times Square, with extraterrestrial beings emerging to announce their presence to a startled humanity. But if the zoo hypothesis is correct, such dramatic contact scenarios are unlikely. Advanced alien civilizations that have been observing human development for millennia would understand the profound cultural shock that sudden revelation would cause. Instead, they might orchestrate a gradual disclosure process designed to minimize social disruption while allowing humanity time to adjust to new realities. Recent government acknowledgements of unidentified aerial phenomena might represent the beginning of such a managed disclosure process. Rather than denying or ridiculing UFO reports, as authorities did for decades, official agencies are now openly discussing encounters with objects that demonstrate apparently non-human technologies. This shift in official stance might reflect behind-the-scenes coordination with alien civilizations that have decided humanity is approaching readiness for contact. The pace and nature of UAP disclosures suggest careful planning designed to acclimate human society gradually to the reality of non-human intelligence. Initial revelations focus on military encounters with superior technology, emphasizing the peaceful nature of the interactions while demonstrating capabilities that clearly exceed human engineering. This approach allows the public to become familiar with the concept of advanced non-human technology without triggering panic or aggressive responses. International protocols for first contact scenarios have been under development for decades, though most remain classified or restricted to government and scientific circles. The United Nations Office for Outer Space Affairs has drafted preliminary guidelines for responding to detection of extraterrestrial intelligence, while various national space agencies have developed internal protocols for handling potential contact situations. These preparations suggest that authorities take the possibility of alien contact seriously, regardless of their public statements. Scientific institutions have also begun preparing for contact scenarios through projects like the SETI Institute's Contact Protocols and the International Academy of Astronautics Post-Detection Task Force. These efforts focus primarily on responses to radio signals or other remote evidence of alien intelligence, but they could be adapted to handle more direct forms of contact. The existence of such preparations indicates growing recognition that contact scenarios require careful planning rather than improvised responses. The role of artificial intelligence in first contact scenarios adds new dimensions to these considerations. Advanced alien civilizations might use AI intermediaries to conduct initial communications with humanity, allowing for real-time interaction despite the communication delays inherent in interstellar distances. Such AI systems might be sophisticated enough to appear human-like in their communication patterns, while actually representing collective alien intelligence or serving as translators between incompatibly different forms of consciousness. Cultural and religious implications of confirmed alien contact would be profound and potentially destabilizing. Many human belief systems assume unique status for humanity in cosmic creation, making the discovery of other intelligent species a theological challenge that could trigger religious crises, or alternatively, new spiritual movements that embrace expanded cosmic perspectives. Alien observers might time contact revelations to coincide with periods of religious and cultural evolution that could accommodate new realities more easily. Economic and political disruptions following contact could be minimized through careful management of the revelation process. If alien technology offers solutions to human problems like energy production, environmental degradation, or resource scarcity, the introduction of such technologies would need to be managed carefully to avoid economic collapse and social chaos. Gradual technology transfer might occur through mechanisms that preserve human agency while providing beneficial capabilities. The education and preparation of human society for contact might already be underway through media, entertainment, and educational content that normalizes the concept of extraterrestrial intelligence. Science fiction films, television shows, books, and games have familiarized multiple generations with various contact scenarios, potentially reducing the shock value of actual contact events. This cultural preparation might be consciously coordinated with alien observers who understand the importance of psychological readiness for successful contact. Individual versus collective contact represents another crucial consideration for first contact scenarios. Rather than revealing themselves simultaneously to all of humanity, alien civilizations might initiate contact with selected individuals or groups who demonstrate appropriate readiness and capability. Scientists, government officials, religious leaders, or other influential figures might receive preliminary contact that gradually expands to broader populations as social adaptation proceeds successfully. The verification challenge for genuine alien contact cannot be understated. Humanity has developed sophisticated capabilities for creating false information, manipulating media, and deceiving populations about significant events. Any contact scenario would need to provide evidence so compelling and widely witnessed that fabrication becomes impossible to sustain. This requirement might influence alien choices about how to reveal their presence in ways that ensure credibility. Two-way communication establishment would mark the most significant milestone in any contact scenario. Moving beyond simple observation or one-way demonstration to actual dialogue between human and alien intelligence would transform the relationship from zoo animals and zookeepers to potential partners in cosmic development. The nature of initial communications, whether focused on scientific exchange, cultural dialogue, or practical cooperation, would set the tone for long-term human-alien relations. Long-term integration challenges would emerge once initial contact scenarios stabilize. How would human society adapt to knowledge of vastly superior alien civilizations? How would human cultural identity survive exposure to cosmic perspectives that reveal our relative youth and limited development? How would human institutions, governments, religions, educational systems evolve to accommodate new realities about our place in galactic civilization? The possibility of contact refusal also deserves consideration. Humanity might be offered opportunities for enhanced contact and integration with galactic civilization while retaining the option to decline and continue independent development. Such choices would test human values about autonomy, growth, and cosmic participation. Different human cultures and nations might make different choices, potentially leading to a bifurcated human civilization, with some groups joining galactic society while others maintain isolation. Recent accelerations in technological development, space exploration capabilities, environmental challenges, and social evolution might indicate that contact scenarios are approaching more rapidly than many expect. The convergence of these trends with increasing government acknowledgement of UAP phenomena and growing scientific openness to extraterrestrial intelligence suggests that we might be living through the final phase of cosmic quarantine. As we prepare mentally and culturally for the possibility that revelation might occur within our lifetimes, we're reminded that first contact, when it comes, might feel less like a bolt from the blue and more like the culmination of a carefully orchestrated process that has been guiding human development toward this moment for far longer than we ever imagined. As our journey through the landscape of cosmic possibilities draws to a close, we find ourselves profoundly transformed by the perspectives we've encountered tonight. The zoo hypothesis has taken us from Fermi's simple lunchtime question through the labyrinthine explanations for cosmic silence, finally arriving at perhaps the most hopeful and unsettling solution of all: that we are not alone, that we have never been alone, and that our apparent isolation is actually evidence of the most sophisticated and benevolent form of alien contact imaginable. The evidence we've explored, from the mathematical inevitability of alien intelligence to the mounting documentation of unexplained phenomena in our skies, converges on a remarkable conclusion. The great silence that has puzzled scientists for decades might not represent absence but presence. The cosmic zoo that surrounds us operates according to ethical principles so advanced that its very invisibility becomes the proof of its existence. We are watched, we are protected, we are studied, and we are loved by intelligences whose patience spans geological epochs and whose wisdom encompasses scenarios we can barely imagine. The zoo hypothesis resolves the Fermi paradox, not by explaining why aliens don't exist, but by explaining why they choose to remain hidden. In doing so, it transforms our understanding of human development from an accidental emergence of consciousness in an empty universe to a carefully tended flowering of intelligence in a cosmos that has been preparing for our awakening since before our species existed. Every step of human progress, from the first use of fire to the splitting of the atom to the first tentative steps toward the stars, has been witnessed and recorded by beings whose technological capabilities make them effectively invisible to our detection methods. This perspective reframes human history and development in profound ways. The challenges we face, climate change, nuclear weapons, social inequality, and environmental destruction, might represent tests that every emerging civilization must pass to demonstrate readiness for cosmic citizenship. Our alien guardians watch not with detachment, but with the concern of teachers whose students approach crucial examinations that will determine their future development paths. The gradual disclosure of UAP phenomena by government agencies might represent the beginning of our graduation from cosmic zoo status, rather than sudden revelation that would traumatize human society. Our alien observers might be orchestrating a careful unveiling process designed to prepare us psychologically and culturally for the reality of galactic civilization. Each new acknowledgement of unexplained aerial phenomena, each scientific paper that takes the extraterrestrial hypothesis seriously, each media portrayal that normalizes the concept of alien intelligence contributes to a vast acclimatization project that might span decades or centuries. The technology demonstrations we observe in UAP encounters serve multiple purposes within this framework. They provide evidence of non-human intelligence, while maintaining enough ambiguity to allow continued natural development. They show capabilities that inspire human technological advancement, while avoiding direct technology transfer that might short-circuit natural innovation. Most importantly, they establish the presence of benevolent superior intelligence that poses no threat to human welfare or autonomy. The timing of our apparent approach to contact readiness coincides with humanity's development of interstellar exploration capabilities through projects like Breakthrough Starshot. This convergence might not be coincidental. Our alien guardians might have been waiting for us to achieve the technological capability for interstellar travel before considering us ready for broader cosmic contact. The ability to reach other star systems, even with simple robotic probes, might represent a crucial developmental milestone that triggers changes in long-standing non-interference protocols. The ethical framework that governs cosmic zoo operations reflects moral sophistication that extends far beyond contemporary human ethics. The patience required to observe a species for millennia without interference, the wisdom needed to determine appropriate intervention timing, and the compassion necessary to protect developing intelligence from premature contact, all suggest alien civilizations that have evolved beyond the territorial, competitive, and short-term thinking that still characterizes much of human behavior. The implications for human psychology and identity are profound as we contemplate our possible status as cosmic zoo animals approaching graduation. Rather than being the culmination of cosmic evolution, we are revealed as children taking our first steps in a universe filled with ancient wisdom and vast intelligence. This perspective is simultaneously humbling and inspiring. Humbling because it reveals the limitations of our current understanding, inspiring because it suggests infinite possibilities for growth and development. The preservation of human cultural diversity and creativity might be among the primary reasons for maintaining zoo-like protection. Our alien guardians might value the unique perspectives, artistic expressions, and innovative solutions that emerge from naturally developing intelligence. Contact too early might homogenize human culture around alien templates, reducing the cosmic diversity that makes each emerging species a unique contribution to galactic civilization. The transition from zoo animals to junior galactic citizens will likely require demonstration of several key capabilities: sustainable relationship with our planetary environment, peaceful resolution of internal conflicts, ethical treatment of other species, and technological development guided by wisdom rather than mere capability. Progress in these areas might be closely monitored by alien observers as indicators of readiness for broader cosmic participation. The educational process inherent in zoo observation works both ways. While aliens study human development, they might also be learning from our approaches to challenges, our creative solutions to problems, and our unique perspectives on existence and consciousness. The cosmic zoo serves not only to protect developing species, but also to preserve the diversity of approaches to intelligence and civilization that emerge throughout the galaxy. The moment of contact, when it comes, might feel less like first contact and more like a reunion with family members we never knew existed. The recognition that we have been watched and protected throughout our development could transform initial fear or confusion into profound gratitude and sense of cosmic belonging. The revelation that we are part of a vast community of intelligence that spans the galaxy might represent the single most transformative moment in human history.